Hello students, welcome to IMS Academy Gate Score Booster session regarding network theory subject. This is the second session. Yesterday we have discussed the first session. In that particular session, we have discussed the variety of questions regarding first and second chapters of network theory subject. Okay. Similarly, in this particular session, okay, we are going to cover the remaining chapters, the variety of questions regarding network theory subject. Okay, this particular subject or this particular session is going to helpful for three branches: EC, electrical and instrumentation with respect to gate exam point of view. Okay, so in the yesterday class I have given one homework question. Whoever tried by this time, you people can mention your answer in the chat. Okay, so all of you quickly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session. Okay, whoever visiting our YouTube channel very first time, kindly subscribe our YouTube channel and then click on the bell icon so that you will be getting instant notifications. Okay, all of you quickly like and share this video link with maximum number of your friends. Okay, so that all your friends, whoever from EC, electrical and instrumentation, and whoever going to write GATE 25 exam or 26 exam, okay, you can quickly share this particular video link with all of your friends so that they also will actively participate in this particular session and each and every student can get maximum benefit from this particular session. Okay, so because of any reason, whoever missed yesterday class, okay, no issue at all. In our YouTube channel, okay, you can watch the yesterday session that is already available in the playlist. You can see regarding network theory session 1 regarding gate score booster. Okay, right. So in the yesterday class I have given this particular question number 18 as a homework. Okay, whoever tried by this time, you people can mention in the chart. Okay, so since I have given as a homework, so now I am not giving any time for you people whoever seeing this question very first time. Okay, no issue. Okay, I will be discussing how to solve this particular question and in which methods we can solve this particular question. I will be covering here. Okay, right. So just observe this particular circuit diagram. Here you are having one load resistor, that is RL. Okay, here across this particular resistor, in order to get maximum power, across the load resistor, they are asking the value of load resistor. The value of load resistor we have to find out. I hope it is clear for everyone. Like when you observe the given circuit, you are having this circuit belongs to DC. Yeah, good evening Gopal. Okay, so here whatever the sources here you are having, this is the DC sources. That means this particular circuit belongs to DC. Okay, DC circuit. So in the DC circuit, with respect to the load resistor, in order to get the maximum power across it, the condition is RL equal to RTH. RL equal to RTH. That means that RTH is nothing but internal resistance of the voltage source. Okay, right. Now what you can do, just remove the load resistor from the circuit. Now the terminals will become open. Across the open circuit terminals, you can calculate the VTH. And similarly, you can short the terminals and you can find the short circuit current, that is nothing but Norton's current. After that, you can apply Ohm's law. By ratio of VTH and short circuit current, you are getting the RTH. That RTH is nothing but RL value, right? Okay. First, I am discussing the method 1. Whatever currently I have explained, in that method, I am going to solve this particular question. Okay. So here, first of all, I have removed the load resistor from the given circuit. Then terminals become open. Across the open circuit terminals, we have to find out VTH. Okay. Similarly, these two terminals, if you short, then definitely the current will flow. Okay. So here the current flowing through this particular short circuit terminals is nothing but ISC. Yeah, good evening Mathan. Right. So see, it is very simple. Whenever terminals are open, across open circuit terminals, you can find the voltage. Similarly, when you are shorting the terminals, you are getting one closed path. Okay, definitely the current will flow. Okay, right. So since here terminals are open, definitely there is no current flows in this particular branch. Okay. Now, if you closely observe, this voltage source, resistor, this resistor and this voltage source, all the elements are connected in series. Okay. So here I1 current is flowing like this. Okay, so accordingly here you are getting the voltage drop across this resistor as 40 into I1. 40 into I1. Okay, here already voltage source value is given 50 volt. Next, here also 10 I1 voltage source value given. Now the same current I1 is flowing like this. Just for reference I am mentioning here. The same current I1 is flowing like this. Now by using Ohm's law, here you are, since current is entering here, positive terminal here, negative terminal here. Okay, right. By using Ohm's law, you are getting 20 I1. 20 I1. Okay. Now here we have to find out VTH. Okay. So before calculating VTH, just observe here. So just you can apply KVL around this particular closed path. Okay, you can apply KVL around this closed path, or in other words you can say for example here, like between these 2 points. Okay, yeah, so between these 2 points, okay, with respect to left hand side you can get one voltage, to the right hand side you are getting one voltage. So here with respect to these two terminals, left hand side and right hand side, voltage should same. Okay, right. So here the resultant voltage minus plus 20 I1, here plus minus 10 I1. That means here I am getting the resultant voltage minus plus, okay, minus plus, yeah, just for reference here I am writing minus plus 20 I1, okay, then plus minus 10 I1. Plus minus 10 I1. Okay. Now here this resultant voltage, what we can write? Since here polarities you can observe minus plus and plus minus, that means we have to subtract. Okay. You can consider in any order your wish, but here right hand side if you observe, here plus minus and plus minus, that means overall you are getting plus minus. So here also I want to get in the similar way, so that we can do the, we can equate easily. Okay, in any manner you can equate based on the possibility. Okay, right. So here I am considering plus minus, that means I am subtracting this one from here. So 10 I1 minus 20 I1. 10 I1 minus 20 I1, that is nothing but minus 10 I1. Or in other words, if you want to get between minus plus 20 minus 10, that is 10 I1, so you are getting overall minus 10 I1. Like that also you can consider. Now here we are having plus minus 40 I1, right, and once again plus minus 50. Since here voltage polarities are same, we can add. Okay, so you are getting 40 I1 plus 50. 40 I1 plus 50. Now you can see voltage polarities are same, plus plus minus minus. That means this voltage and this voltage we can equate. Minus 10 I1 is equal to 40 I1 plus 50. So from here 10 I1 you can bring right hand side, it will become positive. 40 plus 10, that is 50 I1, and this 50 you can bring other side, it will become negative. 10 plus 40 is 50, and here 50. So here 50 is getting cancelled. From here you are getting I1 value as minus 1 ampere. I1 value as minus 1 ampere. Okay. Now here we have to find out VTH. Now just observe, VTH is nothing but what? Either you can consider this side or you can consider this side, your wish. Okay. So for the time being, since see, whichever is easy for you, accordingly you can consider. Because ultimately here VTH is nothing but what? With respect to these two terminals, either you can consider this overall branch or you can consider this overall branch. Okay. You can substitute this I1 value here or you can substitute this I1 value here, your wish. Okay. Suppose from here directly I am writing VTH equal to, okay, for the timing I am substituting here. Okay. Minus 10 I1. So I1 is nothing but minus 1, minus of minus, that is plus, so you are getting plus 10 volt. 10 volt. Or if you want, you can substitute here also. 40 into minus 1, that is minus 40 plus 50 is nothing but, once again, same answer, 10 volt. In any equation you can substitute, there is no issue, because ultimately that VTH is nothing but either this branch voltage or this branch voltage, overall I mean to say. Okay, I hope it is clear for everyone how to find the VTH. How to find the VTH. Now let us calculate the short circuit current. Okay, if any of you are having any doubt regarding this representation, you can mention in the chart. Right. Now here we have to find out the short circuit current. Okay. So just observe, just like here I1 current is flowing. So accordingly you can represent the voltage drop here. So plus minus 40 into I1. Plus minus 40 into I1. Okay. And here voltage polarity plus minus 50. Now the current I1 is coming like this, right? And here if you observe to this particular node, in these two branches currents are entering, right? ISC, I1, that means resultant current will leave in this particular branch. So that is ISC plus I1. ISC plus I1. Okay. Here already voltage source value given. Now with respect to this current, voltage polarities you will be having plus minus like this. And by using Ohm's law, 20 into ISC plus I1. 20 into ISC plus I1. Okay, right. Now if you observe here, okay, see whatever I have represented here in the similar way, now what you can do, just if you closely observe, if you want you can write KVL here, similarly you can write KVL here, your wish. Okay, that is one approach. Whatever the writing with the help of KVL equation, the same logic, okay, if you follow here with the help of like this logic, you can get easily answer in less time. Okay, now what I am telling, just very simple, just all of you carefully observe here. Here with respect to 40 ohm resistor, okay, with respect to 40 ohm resistor, you are having voltage across it what? Voltage across it is plus minus 40 I1. Okay, just carefully observe. With respect to these two terminals, you are having the voltage across it is 40 I1. Okay, now whatever this 50 volt source you are having, okay, just if you closely observe, this terminal is same as this terminal, right? That means this 50 volt source when you are keeping here, okay, so that means this minus sign is coming here, right, and then plus sign here. I hope all of you are getting the clarity. See, it is very simple. Since this terminal is same as this terminal, that means this 40 ohm resistor and this 50 volt source both are contained parallel. With respect to 40 ohm resistance, you are getting plus minus 40 I1. When you are keeping this voltage source here, minus sign is coming top, plus sign is coming at the bottom, right? So that means when two elements are contained parallel, definitely voltage will be same. Voltage will be same. Now here, just observe, here the signs are not same. Here plus and minus. Here minus and plus. That means from here you are getting, you can write in any manner, like 40 I1 is equal to minus 50. So here 1 0 is getting cancelled. From here you are getting I1 value as minus 5/4. Units are ampere. I hope it is clear for everyone. Right? Okay. Now similarly, whatever the logic here we have discussed, exactly similar logic you can apply here. Exactly similar logic. Here with respect to this 20 ohm resistor I am considering. With respect to this 20 ohm resistor. Okay. So the voltage across it is minus plus 20 into ISC plus I1. Okay, right. Now, just like here with respect to 50 volt source, whatever I told, in a similar way, this voltage source 10 I1 you can keep, because here this point and this point both are same. That means when you are keeping this 10 I1 here, then this minus is coming top, right? Minus is coming top, then bottom you are having plus sign, and here voltage across it is 10 I1. Now in this case minus minus plus plus, polarities are same, we can equate. So from here we are getting, like here 1 0 is getting cancelled. So 2 ISC, sorry, yeah, 2 ISC plus 2 I1, sorry, this is small I1, okay, just 1 second. The same current I1, okay. Right. So 2 I1 is equal to I1. So here our objective is to calculate ISC. Okay. So just do the simplification. From here you are getting 2 ISC equal to I1 minus 2 I1, that is minus I1. From here we are getting ISC equal to, okay, I will write in the next step, ISC equal to minus I1 by 2. Minus I1 divided by 2. Okay. So I1 we already got minus 5 by 4. You can substitute here. Minus 5 by 4 and then divide by 2. So here 2 and 4 both are in the denominator. So minus of minus is plus. So you are getting 5 by 8 units are ampere. 5 by 8 ampere. Yeah, good evening, Ashutosh. Yeah, good evening. Right. So here we got VTH value, we got short circuit current. Now in order to find out the RTH, we have to take the ratio of both. That's all. RTH equal to VTH divided by short circuit current. Okay. So VTH value we got here 10 volt. VTH value we got 10 volt. Right. And short circuit current just now we got 5 by 8. 5 by 8. So here 5 2 times and this 8 will come into the numerator. 2 8s are 16. 16. Here since it is a resistance, units are ohm. Okay, RTH value we got 16 ohm. Here in the question they asked that you are having the load resistor RL. In order to get maximum power across it, what should be the resistor value, right? So for DC circuit, RL is nothing but RTH. In order to get maximum power across the load resistor, the condition is RL equal to RTH. Since in this question RTH value is 16 ohm, so the final answer for this question is going to be same, 16 ohm. Okay, right. So 16 ohm there is there in option A. Option A is the correct answer for this question. Okay, this is one method. In order to solve these kind of questions, the first method is you have to remove the load resistor, then across it find out the VTH and then short circuit the terminals. You can find the short circuit current and then take the ratio. From there you are getting RTH. This one method. Okay, just for understanding purpose I have discussed, and this method is helpful especially whenever in the question if they ask only VTH or if they ask only short circuit current or Norton's current. Okay, but suppose same question, suppose if you are getting similar question or similar question like this in the gate exam, you no need to solve the approach that I have discussed in method 1. Now I am going to discuss method 2 with the help of that method 2. Okay, see, whenever you are supposed to find out the RTH, right, first observe the given circuit. First observe the given circuit with respect to the sources. Whether the sources are independent, whether all the sources are independent or not. If all the sources are independent, then we have already discussed in the yesterday class, whatever the independent voltage sources you are having, we can replace with short circuit. If you are having independent current source, we can replace with open circuit. That time, the remaining, whatever the network elements you are having, those are resistors. So that means you are finding the equivalent resistance. That means in order to find the RTH, if you are having the circuit which consists of, along with resistors, if you are having independent sources, then that question you are solving, or you can say while solving that particular question, whatever the concepts you have learned in order to find the equivalent resistance in the first chapter, so the question from second chapter you are bringing into first chapter. Okay, right. Now with respect to RTH calculation, you will be having, based on the type of sources present in the given circuit, we can classify into three types. The first one we already covered. Now here in this particular circuit, if you observe, here you are having independent voltage source. Now what about this source? This is the dependent source. Okay, this is a dependent source. Okay, so whenever you are having dependent source, we cannot replace that voltage source or current source regarding dependent source, we cannot replace with their internal resistance, because it is the dependent source, we don't know its internal resistance, right? So that time in order to find out RTH, whatever the method just now we have discussed, this is one approach. Okay, now I am discussing the second method. Only the most important precaution here, whoever going to solve these kind of questions in the GATE exam with the help of second method, that name of method is test source method. Okay, so especially when you're having a circuit like this, the precaution, what is that precaution? Why I have highlighted here, that is the most important, because most of the students, even though they solve these kind of questions n number of times, even though they are able to get correct answers while they're practicing the questions, but still many of the students, while they're solving these kind of questions in the GATE exam, they used to do the silly mistake. What that silly mistake is, here you have removed the load resistor, right? Okay, then terminals become what? Open. Across the open circuit terminals, you are externally connecting one voltage source or current source. Okay, that is the reason we are calling it as a test source method. But when we are allowed to use that test source, whenever in the given circuit, if there is no independent source present, then only we are allowed to use. Okay, but here already independent source is there. That is the reason what we have to do. Before connecting the test source here, whatever the independent voltage source you are having, that means with respect to case 1, whatever we have discussed yesterday class, exactly same point we have to apply. That means whatever the independent voltage source you are having, you can replace as short. If you are having independent current source, you can replace as open. After that, if you observe this circuit, in this circuit you are having two resistors, and here you are having dependent source. Okay, so that means that particular circuit belongs to case 3. Okay, whenever you are having case 3 circuit, since in the given circuit there is no independent source, across the open circuit terminals, if you calculate the voltage, or if you short the terminals and if you calculate the current, short circuit current or Norton's current, both the values, VTH and Norton's current, both are going to be 0, but surprisingly RTH value never be 0. Okay, in majority of the cases I mean to say. Okay, so that time RTH value, in order to find out, we are connecting externally one source between those two terminals. You can connect either voltage source or you can connect current source. Okay, so that is the reason, even if you are having case 2 circuit, we can solve by using test source method, but before connecting the test source, we have to apply the condition with respect to case 1. Now if you apply case 1 condition, case 2 circuit we are bringing into case 3. Now we are allowed to use test source method, that's all. Right. Now we are going to solve by using test source method. Since here you are having independent voltage source, we are replacing as short. Circuit. Okay. Now here we have to connect the test source. The test source can be either voltage source or current source. Okay, any source you can connect, but with the help of which source we can get the answer quickly. It is very simple. Say for example, between these two terminals, if you connect current source, suppose if you connect current source, okay, because of that, are you able to find out the current here? Or are you able to find out voltage across any element directly? Not possible. But if you connect voltage source, now just observe. Say for example, here I have connected 1 volt source. Now you just observe, 40 ohm resistor and 1 volt, both are connected in parallel. Definitely in parallel voltage will be same. So that means just by connecting voltage source, you are coming to know voltage across this particular resistor. Once if you know the voltage, by using Ohm's law, you can find the current. That's all. Whenever you are having one element connected in parallel, definitely you can connect the voltage source. With the help of that, you are getting the across other element voltage. After that, you are able to find out the current by using Ohm's law. Okay, right. In that manner, you can decide. Okay. Now, since you have connected 1 volt source, now with respect to this source, okay, the current I is flowing like this. We have to find out this current. After that, you can apply Ohm's law. With the help of that, you can find the RTH. That's all. Okay, right. So here, okay, sorry. Here there is a, just 1 second. Yeah, here 1 volt source I have connected across 40 ohm, the same voltage you are getting. The same voltage you are getting, 1 volt. Yeah, 1 volt. Okay. So by using Ohm's law, we can get I1 value as 1 divided by 40. 1 divided by 40 units are ampere. Okay, right. Next just observe. Here I1 current is entering. Whereas here the current I is leaving. That means in this particular branch, if you want to write the current, you can write like I1 minus I. Now if you apply KCL at this particular node, okay, so these two currents are leaving, so plus I minus I both are getting cancelled, I1 is entering, I1 is leaving. Okay, right. Now here with respect to this current, voltage polarities you can keep plus minus here, right. Now you can equate, okay, just I am writing here just for reference, here minus plus 20 into I1 minus I, and then plus minus 10 I1. Now, since here voltage polarities are not same, you can perform the subtraction based on your convenience. You can follow in any representation. For the timing, I am considering plus minus. That means 10 I1 minus this whole term, 20 into I1 minus I. 20 into I1 minus I. So this overall equation is going to be 10 I1 minus 20 I1, that is minus 10 I1, then minus of minus plus 20 I. Now this is the voltage source equivalent voltage. With respect to this overall branch, you are getting voltage polarities are plus minus, right. Now here right hand side, if you observe between those two terminals, you are having 1 volt source, right. So you can equate, here you are having 1 volt. So now we can equate both since polarities are same. Okay. Now when you equate here, you are getting minus 10 into I1 value. Just now we got 1 by 40 plus 20I is equal to 1. Okay. Here 0 is getting cancelled. Right. Okay, minus 1 by 4. You can bring to the right hand side, it will become positive. So 20I is equal to 1 plus 1 by 4. 1 plus 1 by 4. That means 5 by 4 you are getting. 20I1 equal to 5 by 4. Okay. So here 5 4 times. From here you are getting I1 equal to 1 by 16. 1 by 16 units are ampere. I1 equal to 1 by 16 ampere. Now what is our objective? We have to find out RTH value. Okay. So here we have connected externally one voltage source, that is the test source value, voltage source value 1 volt, and in this source the current I is flowing, right. So that current is I. So here we got, sorry, this is I only. Okay, just 1 second. This is I only. Yeah, same current. I only we got. Okay, right. I equal to 1 by 16. Now you can use Ohm's law. That's all. You can use Ohm's law. So voltage equal to current into resistance. So voltage value we have assumed 1 and current value we got 1 by 16 into RTH. So from here you are getting RTH equal to 16 ohm. Yes, so RL equal to RTH. So the final answer going to be same, 16 ohm. Okay, same answer, 16 ohm, right? So in this way, in the GATE exam, whenever you are getting like this question, no need to follow the first method. You can follow the second method. With the help of this method, you can get the answer quickly. Yes, very good, Ashni. Very good, Ashni. I will answer that question. It is very simple. Like say for example, yeah, you can observe here only. You can observe here only. Suppose example. Suppose here like say for example, after this you are having 20 ohm resistor. Suppose here you are having 20 ohm resistor. Now suppose here the terminals are open. Okay, now here in this case you can connect 1 ampere source. So that what will happen? This 1 ampere and 20 ohm resistor both are connected in series. In series same current will flow. Okay, after that by using Ohm's law you can get the voltage across it. Simple logic. Whenever you are connecting a source, okay, with the series of the resistor, that time in series current will be same. After that you can use Ohm's law, you are getting the voltage. And whenever you are getting in parallel like this, okay, in parallel voltage will be same. That is the reason you can connect voltage source. But even for this question, if you connect 1 ampere source, you will be getting ultimately RTH value will going to be remain same. But that procedure may take more time. Okay, suppose if you consider 1 ampere, accordingly you can calculate 1 volt. Okay, sorry, across 1 ampere find out the voltage. After that you can use Ohm's law. From there you can find the RTH. Okay, because when you consider I value 1, so that means RTH is nothing but voltage. Whatever the voltage source across that 1 ampere you are getting, that voltage value is nothing but RTH value. Okay, right. So I hope it is clear for everyone how to solve these kind of questions in method 1 and method 2. Okay, but why I discussed method 1? Because in some question they can ask only VTH, or in some question they can ask only short circuit current or Norton's current. That is the reason I have covered. Okay, right. But whenever you are getting either case 2 circuit or case 3 circuit, definitely you can easily get. Definitely for case 3 we have to use test source method only. Even for solving case 2 circuit, if you follow test source method, you can get the answer quickly. Okay, right. So I hope all of you got the clarity how to solve the given question in the shortcut method, or based on the given question with the help of which approach you can easily solve the question, right? So the students who were not enrolled at our IMS GATE Academy, for all those students, especially who were targeting for GATE 25 exam, so I am recommending for those students to enroll for the Test Series Plus program. Okay, regarding the Google form link, it is already provided in the description of this particular video. Okay, so you will be getting with respect to every subject, chapter level test you are getting, and then subject level you are getting basic subject test, advanced subject test, and then multi-subject test as well. And in addition to all those tests, we are going to provide all new mock tests as well. And in addition to that, we are providing GATE previous year question booklet along with that detailed solution as well, right? Coming to the maths and general aptitude, you are getting 6 branches questions and then the corresponding detailed solutions like EC branch, electrical, instrumentation, computer science, mechanical, civil. And then regarding technical subjects, accordingly, if you are from EC, accordingly EC technical questions and then solutions. Similarly, electrical accordingly. And then you are getting all these features. Okay, so all of you whoever not yet enrolled at our IMS GATE Academy, okay, kindly enroll for the Test Series Plus program, because currently the 20% offer is running. So it is a limited time period offer. So kindly fill the Google form that is provided in the description of this particular video. Okay, and whoever currently in the second year BTech or third year BTech, and whoever want to write the GATE exam in the upcoming years, okay, so those students can enroll for our IMS GATE Academy for live online program. So all these are the features regarding live online program. For more details, okay, or in order to get the complete details regarding our live online program, you can book the free counseling session. Our counselors will discuss in detail about our live online program. Okay, right. Yeah, now I am showing the next question. All of you give it, right? Yes, Hemant. I will be covering based on the possibilities, whatever the questions I have taken for this session, I will be covering, and I will be like while discussing those questions, like after some time while we are discussing the transients, you will be coming across like that part of the circuits also. But if you want, like in this session, I will be giving the conclusion point also, okay, regarding second order circuits. All of you give a try. This is a question regarding two-port networks. Of course, you can consider with respect to network theorems also, okay. But here, in order to solve this question, it is a combination of, you can say, with respect to two-port network and then with respect to network theorems as well. Yeah, first of all, tell me, for solving this question, which theorems we have to apply? Which network theorems we have to apply for solving this question? If you are able to mention the name of the theorems, that means you are on track. All of you tell me, for solving this question, which network theorems are we have to use? Yeah, just observe this figure and that figure. Here you are having 10 volt source. Because of that, like here you can observe you are having one two-port network. This is the port 1, this is the port 2, right? Okay. Similarly here, two-port network, here port 1 and port 2, okay, right? Because of this voltage source, here in this branch current 2 ampere is flowing and here 3 ampere is flowing. Now the question is, when you are having the same network, but here 20 volt source given, here 30 volt source given, but here polarities are minus plus, that time in this branch how much current is flowing? That is the question. Yes, very good, Ashwin. So here we have to use reciprocity theorem, and since you are having two sources, that means whenever two sources are more than that present, definitely we have to take the help of superposition theorem, because reciprocity theorem is applicable only when you are giving excitation at one side and you are finding the response other side, right? But here you are having two voltage sources, right? Whenever two sources are present, definitely we have to, before applying reciprocity, definitely we have to consider with respect to superposition theorem as well, right? Yes, very good, Hemant, very good, Ashwini. Yeah. So first of all, it is very simple. Let us consider only this source. Because of that, we'll find out this particular response. Similarly, that time we will deactivate this source. Similarly, when you are considering this source we will deactivate. Okay, right. It is a combination of both reciprocity theorem and superposition theorem. Okay, right. So case 1, I have considered only the 20 volt source, only this particular source 20 volt source. That means other source I have deactivated. Since you are having other side, like here voltage source means we can short. Suppose if you are having current source, we have to make it as open. Okay, right. Now just observe, it is very simple. Here you are having 10 volt, because of that, here in this branch 2 ampere current flows. Now this 10 volt and 20 volt, what is your observation? 10 volt is multiplied with 2, that time you are getting what? 20 volt. That means whatever here responses you are having, just you have to multiply with 2, that's all. So here 2 into 2, that is 4 ampere. Similarly here 2 into 3, that is 6 ampere. Of course, here in this question, this is not our objective. Our objective is only this one, but just with respect to this figure, I have represented. Okay, right. So when you're having like this diagram, because of 10 volt, here 2 ampere, here 3 ampere. Because of 20 volt, that means you're multiplying with 2, 2 2s are 4, 2 3s are 6. Okay, right. So according to our objective here, Ix, so here 4 ampere, whatever you got, in case 1, I am labeling as Ix1. Ix1 as 4 ampere. Okay. Now we have to consider because of this 30 volt source. Okay. So before connecting directly that one, okay, just for ease understanding, so like here instead of 10 volt, if you are having 30 volt, let us see. So 10 volt become 30 volt, that means 3 times, that means 3 2s are 6 ampere, then 3 3s are 9 ampere. Okay, right. Because of 30 volt, 3 times, that means 3 into 2, 6 ampere, 3 into 3, 9 ampere. Okay, now here just observe, 30 volt source this side, because of that, okay, just for understanding I am writing like this, 30 volt source here you are having, okay, because of this, okay, 6 ampere current is flowing here and 9 ampere current is flowing here. Okay, I am not bothering about this 6 ampere at this point of time, because just observe here, when you have given 30 volt source one side, because of that our objective is response in other side, right? So I am not bothering about this 6 ampere, I am just focusing on with respect to, because of this source I am focusing this response. Okay, just observe, because of this 30 volt source you are getting, 9 ampere. When you are having 30 volt source, voltage polarity is plus minus here, 9 ampere is going downwards. Okay, right. Now even if you interchange the source and response, okay, so that means 9 ampere will be going like this because of 30 volt source when you are keeping here. That means voltage polarities you are keeping like this, okay, then response will come here. Since it is downward, exactly same. But here as per the question, instead of plus minus 30, they have given minus plus, right, minus plus. So when you have changed the voltage polarities, then because of this, here current direction will change. So since the current direction earlier it is downward, now it will be upward. Right. Now just observe. So here what is the conclusion point? Very simple. You are having like this network. That time I have connected minus plus 30 volt like this here in the second port, whereas the first port I have replaced this 20 volt source as short circuit. Right. Now you are having this minus plus 30 volt here because of this source. When this source is not present, you are getting 9 ampere upward. That means in the same direction you are getting, right? So that means here conclusion point is what? Ix2 equal to 9 ampere. Suppose if the direction is opposite, I could have written minus sign. Since the direction is same, when you are saying upward, that means the current is going like this, right? This current Ix, right? This current Ix and this 9 ampere, both are in the same direction. So because it is a case 2, Ix2 equals 9 ampere. Now here our objective is very simple. When 20 volt source is present and here this side, and minus 30 volt source is present this side, because of both the sources, in this particular first port, in this direction, how much current is flowing? Okay, here direction is same, here also direction is same, right? Since the directions are same, now by using superposition theorem, we can add both the currents, that's all. Okay, right. By using superposition theorem, in short I am writing SPT, Ix equal to Ix1 plus Ix2. Ix1 we got 4 ampere, right? Ix2 we got 9 ampere. So 4 plus 9, that is 13 ampere. 4 plus 9, 13 ampere. Yes, that is there in option B. Option B is the correct answer for this question. Okay, I hope it is clear for everyone. Yeah, all of you give a try. Next question. This is the MSQ question. Which of the following options is or correct? This question is of MSQ. Either one option or more than one option can be correct. At least you can choose whichever options after trying. No, like among A and B you can decide which options are going to be correct. Similarly among C and D, based on your convenience, at least you can find out either this set or this set. And then finally we will combine, like overally out of 4 choices, which choices are going to be correct. Yeah, first of all, if you observe these equations, like here V1, I1, I2, I1, I2, V1 and then V2. And here if you observe, you are having Y parameters. Okay, all the Y parameters you are having Y11, Y12, Y22, Y21. Okay, so this question you can solve in 2 methods. Okay, I am just mentioning method 1 how to solve this question, but I am giving as a homework. Okay, I am just giving the approach, you can try later. Say for example here, whatever the equations here you are having, try to bring in such a way that you can bring in this particular format, like V1 equal to Z11 I1 plus Z12 I2. Okay, with respect to Z parameters I am talking. Okay, similarly V2 equal to Z21 I1 plus Z22 I2. That means what you are doing, whatever the given equations are there, you can do simplification or represent in such a way that V1 in terms of I1 I2, V2 in terms of I1 I2. So that means whatever I1 coefficient, I2 coefficient, here you are getting accordingly 4 parameters you are getting, right? So that means from here you are getting Z matrix you are getting like Z11, Z12, Z21, Z22. In this question, if they ask Z parameters, this is the approach. But in this question, they have given Y parameters. So whatever the Z matrix you got, you have to perform inverse. You have to perform inverse. Y equal to Z inverse. Y equal to Z inverse. I hope all of you know how to perform inverse of the matrix. Inverse is nothing but adjoint by determinant. Adjoint by determinant. So here adjoint means whatever in this diagonal you are having, these elements you have to swap. Okay, these elements you have to swap. That means you are getting Z22, then Z11. Okay, in this diagonal you have to swap the elements. After that, in this diagonal you have to change the polarity. You have to change the polarity. Here minus Z12. Here minus Z21. This is with respect to adjoint of the matrix, and then I hope everyone knows regarding determinant. Determinant means AD minus BC, that's all. Z11, Z22 minus Z12, Z21. So here this Z22 divided by this overall term, that is nothing but Y11. Similarly, minus Z12 divided by whole term, that is Y12. Similarly, minus Z21 divided by this term, that is Y21. Z11 divided by this term, that is Y22. Like that you can choose among the 4 choices whichever options are going to be correct. Okay, this is one method For the time being, I'm not solving in this method, but I have given the approach, how to solve this particular question. You can give a try. This is the homework question. Okay, just for reference, here I'm mentioning this is the homework. Method 1 is the homework. But I will solve this question in second method. I will solve this question in second method. What is the second method? Here I have given the first method is what? In terms of z parameters, right? Since they are asking this question in terms of y parameters, directly try to get the given equations in terms of y parameter standard equations. That means I1 in terms of y parameters, I2 in terms of y parameters. That means you can write here just for reference. Okay. I hope all of you know the standard equations like I1 equal to y11 v1 plus y12 v2, I2 equal to y21 v1 plus y22 v2. Okay, right. So with that understanding, okay, from the first equation, I am bringing I1 to the right hand side, it will become positive. Okay, I am getting the other side terms are 3v1 plus 4i2. Here our objective is I1 in terms of V1, V2. As of now I got V1, but here V2 is required. Okay, no problem. But what is the equation currently I got? This equation you can substitute here. Okay, this equation you can substitute here. Then what will happen? In place of I1, I am substituting this overall term. Okay, right. So here 4 into 3V1 plus 4I2. Okay, 4 into 3V1 plus 4I2. Right. Then plus 2I2 minus 6V1 is equal to 5V2. Right. Okay. Next. So just observe here. 4 2s are 8. Sorry. Okay. 4 3s are 12. 12V1 then minus 6V1. 12 minus 6, that is 6. 4 3s are 12 minus 6, that is 6. Okay. Next, 4 4s are 16. 16 plus 2, 18. 18 I2. Okay. So up to here we have done with respect to V1 and with respect to I2. Okay. On the right hand side you are having 5V2. Now just rearrange this equation. So 18 I2 is equal to 5V2. Okay, I am writing first V1 and then V2. Okay, here minus 6V1 plus 5V2. Okay, 18I2 equal to minus 6V1 plus 5V2. Now whole equation you can divide with 18. From there you are getting I2 equal to minus 6 by 18, that means minus 1 by 3. Minus 1 by 3 into V1 plus 5 by 18. 5 by 18 into V2. Now you can compare this one with the standard equation. Okay. So, right. Okay, just for reference I am labeling this one. This equation you can label as 1 and this equation I am labeling as 2. Okay. Now this equation you can compare with the standard equation like I1 equal to y11 v1 plus y12 v2. Okay. So that means from here you are getting y11 equal to minus 1 by 3. Sorry. I2 equal to y21 v1. y21 v1 plus y22 v2. So y22 equal to you are getting 5 by 18. Units you will be getting mho. For the timing I am not representing. Because it is a admittance, units will be mho. If it is a impedance, units will be ohm. Okay. Y21 is minus 1 by 3. Y21. So here you can observe 6 3 times. That means you are getting minus 1 by 3. Yes. So this option is correct only. Y21. Okay. Next. Y22 5 by 18. Yes. This is also correct. As of now we got C and D are correct. Now we have to verify among A and B which options are going to be correct. Okay, I hope it is clear for everyone up to this step. Now let us proceed further in order to observe among A and B which options are going to be correct. Now whatever the equation here I2 you got, that equation number 2 you can substitute in equation 1. Okay, substitute 2 in 1. So from here you are getting I1 equal to 3v1 plus 4 into I2 you are having, that I2 is nothing but this entire expression, right? I2 is nothing but this entire expression. So you are having minus 1 by 3 v1 plus 5 by 18 v2. 5 by 18 v2. Okay, right. Now you can do the simplification, that's all. So here, from here you can do the simplification. 3 minus 4 by 3 into v1, then 4 into 5 by 18 v2. So here 2 times, here 9 times. Okay, then 3 3s are 9 minus 4, that is 5 divided by 3 into v1 plus 2 5s are 10 divided by 9 v2. Okay, now you can compare with the standard equation. I1 equal to y11 v1 plus y12 v2. Y11 you are getting 5 by 3. Okay, then y12 10 by 9. 10 by 9. Okay, just observe here. Y11 here 6 5s are 30, 6 3s are 18. Okay, 5 by 3 you are getting. Yes, exactly same, 5 by 3. So that means option A is also correct. Option A is also correct. Right, now coming to y12, here 3 by 7 is there, but here we got 10 by 9. 10 by 9. Both are not same. Both are not same. That means option B is not correct. For this question, 3 choices are correct: A, C, and D. In this way, for MSQ question, you have to verify each and every option whether it is correct or not. Okay, whichever options are correct, accordingly you have to choose. Okay, right. Next one, all of you give a try. So here we have to find out the H parameters. Here we have to find out the H parameters. They have given the Z parameters. Yeah, whoever got the answer at least for any of the 4 parameter, at least you can mention the chart. I asked for all the 4 parameters regarding H. Okay, so at least if you got either H11 or H12, H21, H22, any of the parameter, okay, whichever parameter value got, you can mention the chart. Whoever getting the correct answer, okay, I will appreciate them. Whoever getting wrong answer, don't hesitate. At least with the help of, like, when you're focusing regarding the explanation, that time you can cross check where you done the mistake, at least what are the mistakes you have done. So those are the learnings for you. You can avoid those kind of silly mistakes in the upcoming GATE exam. Okay, right. In this question, they have given Z parameters and you are supposed to find the H parameters. Okay, so first of all, just write with respect to H parameters the standard equations. Okay, I hope all of you familiar with respect to H parameters. With respect to H parameters, the standard equations, like V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2. V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2. So these are the standard equations with respect to H parameters. Okay, right. Now here our objective is with respect to H parameters. Okay, right. So just if you observe here, case 1 you can consider V2 equal to 0. Suppose case 1 if you consider V2 equal to 0, okay, because of that you can find out 2 parameters, right? So here H11 is nothing but V1 by I1. V1 by I1 when you are keeping V2 0, right? Okay. Next H21 is nothing but I2 by I1. That's all. Yes or no? I2 by I1 when you are keeping V2 0. Okay, similarly we'll talk about regarding other 2 parameters in some time. Okay, first of all, our objective is we have to make V2 0. With the help of that, you have to find out the ratio of V1 and I1, you are getting H11, ratio of I2 and I1, that you are getting H21. Okay, right. Now, see, with respect to GATE exam point of view, whatever the 2-port network parameters, like from one set of parameters to other set of parameters, conversion formulas no need to by heart, no need to remember with respect to GATE exam point of view. Okay, so just if you remember the standard equations with respect to Z parameters, Y parameters, T parameters and H parameters, that is more than sufficient. Okay, in this manner if you are able to recall, after that what is the procedure currently I am discussing, similar procedure you can do even in the GATE exam. Okay, but here for practice, that is the reason I am asking all the 4 parameters, but in the exam they can ask either 1 parameter or 2 parameter, etc. But if the question is too much lengthy, definitely they will ask either 1 parameter or 2 parameters, but if the question is simple, then they can ask all the 4 parameters. Okay, right. Right. Now you can write, since you are having Z parameters, accordingly I am writing the Z parameter equation, but I am not writing the equation since you are having values, accordingly I am directly substituting. Okay. With respect to Z parameters, you are having like V1 equal to Z11 I1. Okay, Z11 here it is 12 into I1 plus Z12 4 into I2. V1 equal to Z11 I1 plus Z12 I2. Okay, V2 equal to Z21 I1 plus Z22 I2. Okay, right. Now just observe here. We have to consider V2 0. In these 2 equations, here V2 is 0 present here. So this case I am considering here. Okay, so just substitute in place of V2 0. Now 36 I1 plus 18 I2. 36 I1 plus 18 I2. So here 18 you can take common. Okay, 18 ones and then 18 twos. Okay, from here you are getting I2 equal to, This term you can bring other side, it will become negative. So you are getting minus 2I1. I2 equal to minus 2I1. Okay. Now just observe this equation. Here I2 by I1 we want, that means I1 you can bring this side. I2 by I1 is nothing but what? Minus 2. Minus 2. So from here, as of now, we got one parameter. H21 is equal to minus 2. Yes or no? I2 by I1 is nothing but minus 2. Since it is a ratio of two currents, units won't be there. It is a constant. Okay, right. So we got H21. Okay, right. Now we should get H11, that is nothing but V1 divided by I1. Okay, so V1 here you are having, and whatever the I2 here you got, that one you can substitute in this particular equation. Sorry. Yeah. So whatever I2 equation you got, substitute here, so that right hand side you are getting in terms of I1, left hand side you are having V1, then you can take the ratio, that's all. Okay. So from here you are getting like V1 equal to, okay, just by observation, here first term is 12I1, then plus 4 into I2. I2 just now we got minus 2I1. Okay, so minus plus 4 into minus 2 is nothing but minus 8. 12 minus 8 is nothing but 4. So from here you are getting V1 equal to 4I1. Okay, so just observe here. V1 by I1, that means you are getting 4. That is nothing but your H11. H11 equal to 4. Now what are the units? Here you are taking ratio of voltage and current, that is nothing but impedance or resistance. Units will be ohm. H11 equal to 4 ohm. Okay, so like this logic you can follow in the GATE exam. Okay, right. So I hope all of you understood how to find the H parameters. As of now we have discussed 2 parameters. Okay, now let us find out other 2 parameters regarding H parameters. Okay, H11, H21 we got as of now. Here now our objective is H1 to H22, that means other variable, that is I1 we have to make 0, that's all. Okay, case 2 I am considering. Case 2 I am considering I1 equal to 0. I1 equal to 0. I1 equal to 0. Okay. When you consider I1 0, what is happening? H12 is nothing but what? V1 by V2. Okay. H12 is nothing but V1 by V2. V1 by V2. Okay. Similarly, H22 is nothing but I2 by V2. I2 by V2. I2 by V2. Okay. Here condition we are considering I1 0. Okay, just observe here. Here I1 0 means here, right? First term I1 is there, that is 0. Now you can consider, okay, the moment I1 is 0, V1 you are getting 4I2. V1 equal to 4I2. Okay, V1 equal to 4I2. Next, V2. V2 means this equation. Here I1 is 0, 18I2. Now here I2 is getting cancelled. Then 2 2s are 4, 2 9s are 18. That means you are getting 2 by 9. Here in this case, ratio of 2 voltages, definitely it is a constant. Units won't be there. Okay, right. Next, here I2 by V2. See, just now only V2 we got, 18I2. Okay. So I2 divided by V2 is 18I2. So here I2 is getting cancelled. So you are getting 1 by 18. In this case, it is a ratio of current and voltage. So that means units you are getting mho. Voltage and current means ohm, reverse or reciprocal, that is mho. That's all. Okay. In this way, you can calculate regarding any set of parameters when they have given, if they are asking other set of parameters with respect to two-port networks. I hope it is clear for everyone. Now the next question, all of you give it right. This is a dead easy question. I am not keeping the timer. All of you just read the choices. This question is MSQ. This question is MSQ. Either one option or more than one option can be correct. Okay, question is of MSQ. All of you give a try. It is dead easy question. Whoever know the conditions with respect to symmetrical and with respect to reciprocal, they can easily answer this question correctly. At least you can give a try. With respect to symmetry, whichever two options are there, like here symmetrical based two choices are there, B and D, you can decide among B and D which options are going to be correct. Similarly, with respect to reciprocal, you are having two choices A and C. Among A and C, which options are going to be correct? All of you give a try. Yes, just observe here, it is very simple. See, first I am discussing with respect to symmetrical condition. Okay, so regarding Z parameters, Z11 equal to Z22. Okay, when you are having Z matrix, the first parameter and last parameter both should be equal. Similarly for Y parameters, exactly same. Even for T parameters or ABCD parameters, the first and last parameter is going to be same. Okay, now coming to the H parameters, determinant of H matrix, that is nothing but H11 H22 minus H12 H21, that is equal to 1. Okay, so these three are having one relation and the H parameters is having another relation. Okay, right. Now coming to the reciprocal. Okay, coming to the reciprocal, Z12 equal to Z21, Y12 equal to Y21. Okay, now like this format you are getting with respect to H parameters, H12 equal to minus H21. Okay, you are getting minus sign. Okay, H12 equal to minus H21. Coming to the T parameters, you are having determinant of that matrix equal to 1. Here you got determinant of H matrix equal to 1. Like the determinant, here you are getting for T matrix. Okay, and here like this relation you are getting, but sign is changing. Okay, only one side sign you have to put minus. Okay, now just observe with respect to symmetrical condition. Symmetrical for H parameters, determinant equal to 1, yes. H11 H22 minus H12 H21, yes, this option is correct. Okay, symmetrical, right. Next, for ABCD parameter, A equal to D, but here A equal to C, that means this is not correct. Now see the reciprocal, Z12 equal Z21, but here Z11 equal Z22, so this is not correct. Next, ABCD parameters, determinant of the matrix equal to 1, yes, it is correct. So for this question, two choices are correct, A and B, A and B. Okay. Yeah, next question, all of you give a try. I am giving 1 minute time. So here you have to find out with respect to T parameters, you are having one parameter is C. Okay, that C parameter you have to find out, but here you are having two choices in terms of Z parameters, two choices you are having H parameters. Whatever the procedure earlier we have discussed with respect to H parameters from Z parameters, like that here you can do. So this question is also MSQ. Yeah, just like earlier, last but one question, exactly similar procedure. It is very simple. First of all, here we have to find out C parameter with respect to ABCD parameters. With respect to ABCD parameters or transmission parameters, first write the standard equation. V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. Here, since in the question they are asking C parameter, so C parameter you are getting by making I2 value 0. Here I2 value 0. That time, C is nothing but I1 by V2, I1 by V2. Okay, right. Now like that expression you should get I1 by V2 by making I2 value 0. Okay, with respect to Z parameters and then with respect to H parameters. It is very simple. V1 equal to Z11 I1 plus Z12 I2, V2 equal to Z21 I1 plus Z22 I2. Okay, now here the condition is I2 equal 0. So that means here you are putting I2 0. Okay, when you are putting I2 0 here, I1 and V2. So that means you have to focus this equation, that's all. Okay, here when you are keeping I2 0, okay, when you are keeping I2 0, right, so this term is 0, right, then you are getting I1 is V2 is nothing but Z21 I1, Z21 I1, so I1 is getting cancelled, so you are getting 1 by Z21, 1 by Z21, right. So 1 by Z21 you are having in option A. So the moment you are choosing option A, option C we can eliminate, right. Okay, next with respect to H parameters, we already discussed the standard equations. V1 equal to H11 I1 plus H12 V2, I2 equal to H21 I1 plus H22 V2. Here also the condition is same, I2 equal to 0. Okay, so here I2 value we have to keep 0, then I1 divided by V2. That means, okay, the moment you have kept I2 value 0, the moment I2 value 0, okay, just from this equation, okay, just rearrange, that's all. Here you are getting H21 I1, H21 I1 is equal to minus H22 V2, minus H22 V2. Okay, so here I1 divided by V2, that means you are getting minus H22 divided by H21, that's all. Minus H22 divided by H21, that is there in option B, so we can eliminate option D. Option D we can eliminate. Okay, in this way, whenever you are getting MSQ questions in the GATE exam, after reading the question, you can decide whether you can solve the question in less time or whether it will take more time. If you can solve in less time, you can do at that time. Whichever MSQs are taking definitely more time, you don't attempt those MSQ questions in the first 1.5 hour during the GATE exam. Better you can solve those questions in the last 1.5 hour. Okay, right. Yeah, next question. So up to here, what are the questions we have discussed? Okay, regarding network theorems, we have discussed one homework question which I have given yesterday class. That question we have covered. After that, next question we have covered based on network theorem and based on two-port network, and then remaining questions we have covered from the two-port networks. Okay, right. Now we are going to solve the questions regarding transient analysis. In general, majority of the students in the regarding the network theory subject, generally majority of the students will fail very difficult regarding the transients chapter related questions regarding network theory subject. Okay, whoever attending this particular session, definitely whatever the models or whatever the questions here we are covering, definitely in those models you are getting the very good command. Definitely whoever attending this session and writing the GATE 25 exam, definitely you people can score either 1 mark question or 2 mark question easily. Easily I am telling, but even when they are giving like some complicated question also, at least whatever the knowledge you are receiving from this particular session, at least you will be in a position to try. Okay, but whoever already done very good revision earlier and whoever attending this session, definitely whatever the transient questions you are getting in your GATE exam, definitely you can score, maximize in the GATE exam. Okay, all of you give it a try. In this question, you have to find out the time constant. You have to find out the time constant. All of you give it a try. It is a simple question. I hope all of you can get the correct answer. So here in this question, if you observe, you are having current source and then resistors, right, and then inductors. Okay, so whenever you are having the circuit, okay, regarding the time constant, okay, so when you are having combination of resistors and inductors, that time constant is what? L equivalent divided by R equivalent. If you are having combination of resistors and capacitors, then R equivalent into C equivalent, right? So this question is based on inductors and resistors. First of all, you have to find out the L equivalent. Okay, so first of all, so just observe here, in this entire circuit, okay, you are having 3 inductors. Now with respect to these 2 terminals, find out the equivalent inductance. Okay, so yesterday also I have mentioned, with respect to resistors and inductors, the formulas are going to remain same. The format wise, I mean to say, regarding series connection, similarly regarding parallel. Okay, right. Whereas for capacitors, exactly opposite. Okay, right. So here 2 Henry, 2 Henry, both are connected in parallel and having the equal value. That means the equivalent inductance you are getting 1 Henry, 2 Henry parallel with 2 Henry, that is 1 Henry. Now here you are getting 1 Henry and that 1 Henry in series with this 1 Henry. Overall you are getting L equivalent here. L equivalent here you are getting 2 Henry. Okay, direct step I have written 1 Henry plus 1 Henry, that is 2 Henry. Now whatever the equivalent inductance you got, that is one inductor. Now that inductor you are removing from the circuit, then terminals will become what? Open. Okay, terminals will become open. Across the open circuit terminals, you have to find the R equivalent. You have to find the R equivalent. Now in order to find the R equivalent, okay, now whatever the concept already we have discussed in the maximum power transfer theorem, even in today's session while solving that question, the same approach you can apply here, the same approach, okay, even in today's class or even yesterday class. Okay, now here if you observe, like this question, if you observe after removing the equivalent inductance from the circuit, whatever the circuit here you are having, that belongs to case 1. That means this model we covered in the yesterday class. Okay, now in this part of circuit, here you are having current source, independent current source. That one you have to remove, or that source you have to deactivate. Current source value 0, that means it is a open circuit. Current source value 0, that means open circuit. If it is a voltage source, we have to make it as short. Now all of you tell me, with respect to these 2 terminals, what is the R equivalent? What is the R equivalent? At least now you can give it right. It is very simple. All of you can give it right. Don't hesitate whether your answer is correct or wrong. See, the moment here terminals are open, in this branch there is no current flows. Okay, in this branch there is no current flows. If no current flows in this branch, how this 1 ohm resistor and 9 ohm resistor are connected? Series, that's all. Whatever the current is flowing here, the same current will flow like this, correct? The moment here in this branch there is no current flows, this resistor you can remove. It is an open circuit, right? 1 ohm and 9 ohm both are connected in series. R equivalent you are getting 1 plus 9, that is 10 ohm. Okay, in this manner you have to find out the R equivalent. Okay, right. Now you can find the time constant. In this question we have to find the time constant. Okay, so time constant tau is nothing but L equivalent divided by R equivalent. So L equivalent 2 Henry divided by R equivalent is 10. 2 by 10, that is 0.2. Units are seconds. Here it is a time constant. Units you will be getting in the order of second. Here since they have given normal values, or you can get in the order of millisecond or microsecond, etc. based on the order of the units they have given. Okay, right. So with this understanding, all of you give a try for this question. Here also you are supposed to find the time constant of the given circuit. Here at t equal 0 instant we are closing the switch. Okay, whenever in the question if they don't specify, okay, regarding the time constant, for what case you have to consider? Okay, by default it is for t greater than or equal 0. Okay, that is the condition you can consider by default, unless otherwise in the question they specify that for t less than 0. Okay, after the switching action, okay, after the switching action onwards, that means from t equal to 0 onwards up to infinity, whatever the circuit you are having, overall circuit, for that circuit you have to find the time constant. Okay, all of you give it a try. Yeah, just see the beauty of this question. This is a very interesting one. This is a very interesting one. So when you consider the circuit for t greater than or equal to 0, okay, that means here the switch is in the closed position up to t equal 0 minus switch was open. From t equal to 0 plus instant onwards, the switch is in the closed position, right? So first of all, you have to consider the switch is in the closed position. Okay, right. Okay, next. Okay, after switch closed, okay, for t greater than or equal to 0, you are having what in the given circuit? You are having voltage source and then resistors and then capacitor. Okay, so here in this question only one capacitor is there. Definitely C equivalent will be that capacitance value. Okay, C equivalent I am writing here 0.5 farad. Okay, C equivalent we are getting 0.5 farad. Okay, now whatever the C equivalent you are having, okay, that particular capacitor, okay, since you are having only one capacitor, obviously equivalent capacitance is same. Now you remove the capacitor from the circuit. Okay, remove the capacitor from the circuit, then terminals will become open, just like the previous question. In the previous question, what we have done? In the previous question, we have found the L equivalent. After that, the equivalent inductance we have removed from the circuit. Equivalent inductor we have removed from the circuit. Terminals become open. Across the open circuit terminals, we have to find R equivalent. That's all. R equivalent. Okay, right. Now here in this circuit, here you are having 5 volt source, that is the independent voltage source. We have to replace this voltage source as short circuit. Short circuit. Okay. Voltage source we have to replace as short. That's all. Okay. After that, see, after you are applying that basic concepts, now in order to find the equivalent resistance, this circuit you are bringing into what? First chapter. That's all. Whatever the questions, good number of questions we have covered in the yesterday class, we have discussed. Initially only we have discussed with respect to inductors, with respect to capacitors, even with respect to resistors, equivalent impedance or equivalent resistance, equivalent inductance, equivalent capacitance, etc. Right. Now, while if you want to become perfect or expert in the network theory subject, if you become perfect in the first and second chapters, that is more than sufficient. That is more than sufficient. But only thing, in the other chapters like third chapter, fourth chapter, fifth chapter, according to that concept, if you know the basic, okay, like what condition you have to consider or what kind of equivalent circuit you have to draw, etc. Regarding that basics, if you are having the clarity, that is more than sufficient. Whatever you have learned in the first and second chapter concepts, with the help of that, you are going to solve the questions regarding third chapter, fourth chapter and fifth chapter. Okay, right. That is the most important. That is the reason, like in the network theory subject, generally majority of the students, why they will feel the network theory subject is a tough, because they are not fundamentally strong. That means either first and second chapters they are not strong, or even whatever the third chapter, fourth chapter, fifth chapter you are having, regarding the terminology, whoever not having the clarity, then definitely they are going to do more number of silly mistake. Because of that, definitely you are not getting correct answer. Because of that reason, generally, even though they can solve the questions correctly, but because their lack of the basics, that is the most main reason I can say why the students are facing the problem in network theory subject. But if you are strong in the basics and if basics are clear for you, then no matter the level of the question, no matter the question from whichever chapter, because if you are able to solve the network theory questions correctly, directly you are getting the benefit from network theory subject in the GATE exam, and indirectly it is going to help you while solving the analog circuit questions as well, right? Regarding the equivalent circuits, okay, in terms of finding the input, like regarding that particular amplifier equivalent circuit in terms of gain, current gain, voltage gain, or input impedance or output impedance, in order to calculate those kind of parameters in the analog circuit, definitely what are the concepts you have learned in the network theory is going to help a lot. Okay, so directly you are getting the benefit from network theory subject, indirectly it is going to help you in order to score even analog circuit subject questions. Network theory subject is going to play a vital role. Okay, right. Okay, now just you have to find out the R equivalent with respect to these two terminals, right? Okay, so just like yesterday class, I have put the labeling, okay, representation. So accordingly you can consider, say for example here, this node I am labeling as A, this this node I am labeling as B, and this node, this node, this node, all are same only, yes or no? Okay, so you can keep same node B, same node B, right? Okay, then just observe here. Okay, so this is one more node I am considering like C. Okay, just if you carefully observe, between the terminals C and B, we are having 2 ohm resistor. Okay, next, in this path you are having 2 ohm. Okay, now you are having one more path like this. Between C and B, you are having 1 ohm. That means between two terminals C and B, you are having 2 ohm, 1 ohm. Both are contained in parallel, right? So this is the first important observation. 2 ohm in parallel with 1 ohm. That means you are getting 2 into 1 divided by 2 plus 1. That is nothing but 2 by 3 ohm. I hope all of you got the clarity. This 2 ohm resistor, this 1 ohm resistor, both are contained in parallel. Okay, right. After that, what you are getting? Here between A and B, okay, just for understanding, I am drawing the circuit. Here between B and A, okay, we are having 1 ohm resistor. Okay, then between A and C, we are having 0.5 ohm. Between A and C, we are having 0.5 ohm. Okay, next, just now we got between C and B. Okay, between C and B, we got one resistor. Okay, that is 2 by 3. Okay, this is the terminal C. This 0.5 ohm for the timing I am writing like 1 by 2 ohm. Okay, now what is our objective? We have to find the equivalent resistance between terminals A and B. Between terminals A and B is our objective. Okay, between terminals A and B is our objective. So that means here between A and B we are having 1 ohm. Okay, here we are having 1 ohm. Okay, in this path, and you are having one more path like this between the terminals A and B only. Now in this case, these two resistors are contained in series. That's all. 2 by 3 and 1 by 2 both are contained in series. Okay. Okay, so just for the timing I am writing here 2 by 3 plus 1 by 2, that is nothing but here LCM is 6, 2 2s are 4 plus 2 3s are 6, 3 into 1 is 3. So 4 plus 3 is 7, 7 divided by 6, that is the, you are getting between A and B in this branch, right? Now whatever you got here 7 by 6 and here 1 ohm, both are contained in parallel, right? So R equivalent is nothing but 1 ohm in parallel with 7 by 6 ohm. In this way, regarding the network theory subject, if you are able to identify which elements are contained in series and which elements contained in parallel, after that you can easily solve. But generally, even though you are good at like whether the elements contained in series or contained in parallel, but still majority of the students used to do the silly mistake here, because you might be assuming based on your way, but whether your assumption is correct or not, how to figure out? If you putting the labeling like this nodes, and whichever node point is same, everywhere you can keep same terminology instead of representing different, so that you will be coming to know. Here between C and B you are having 2 ohm, here also between C and B you are having 1 ohm. And the most important thing here, with respect to whichever terminals you have to find out the equivalent resistance, those two terminals always you keep the focus till the last step. There you should not do in between simplification. Say for example, sometimes few students may do here 1 plus 0.5 is 1.5, after that parallel with 2 by 3. But that is with respect to B and C. But here the context is with respect to A and B. That is also most important. Okay, right. Now here you are getting 1 into 7 by 6 plus, sorry, divided by 1 plus 7 by 6. So here numerator you are having 7 by 6, divided by denominator you are getting 6 plus 7, that is 13 by 6. So 6 is getting cancelled, you are getting 7 by 13 ohms. This is the R equivalent. C equivalent we already got 0.5 farad. Okay, for the timing if you want this one you can represent as 1 by 2 farad. Okay, right. So now the time constant, just you can multiply, that's all. Tau equal to R equivalent into C equivalent. R equivalent is 7 by 13 into C equivalent 1 by 2. So you are getting 7 by 26. 7 by 26. Yeah, all of you can do the simplification. This one you will be getting 0.269. 0.269 units or seconds. Okay. In this way, you have to find out the time constant. I hope all of you got the clarity. Okay. If any of you are having any confusion or doubt, you can mention the chart. I will clarify. Right. Next question. All of you give it a try. Yeah, this is a very interesting question. See, regarding transients, why majority of the students may do silly mistake, I already mentioned earlier. The basics wise they are not clear. That is the only reason. If you are basics wise strong, you can easily solve. See here, when you read the question, you might be getting one trap. Okay, what they are asking, just read the question once. In the circuit shown in the figure, the switch is open. The switch was open for a long time and is closed at t equals 0. See, like this sentence in some question they will be giving, in some question they may not give. But by observing the switch arrow direction, you will come to know whether we are closing the switch or whether we are opening at that particular time instant. Okay, here you can observe the switch we are closing at t equals 0. That means up to t equals 0 minus switch was open position, and here at t equal to 0 plus they are asking the current flowing through this 2 ohm resistor. Since in the question you are having that at t equals 0 plus, since they are asking the current flowing through 2 ohm resistor, because of that majority of the students directly they are drawing the equivalent circuit at t equals 0 plus. But whatever the answer you are getting, it may be correct or may not be correct. Most of the cases you may get wrong. Why? The reason is very simple. Here just observe, like up to t equals 0 minus, the switch is open position, right? Switch is in open position. That means this current source is connected to this part of the circuit. Okay, so from minus infinity to 0 minus, okay, this independent source was connected. Because of that, here you are having capacitor. Similarly, even if you are having inductor. Okay, so with respect to capacitor, it has, you got maximum voltage across it. Okay, that means the capacitor is reached to the steady state. Similarly, if you are having inductor, it has reached to the steady state. That is the most important conclusion point. Even though they are asking at t equals 0 plus, first and foremost you should verify just before that switching action. Okay, just before the switching action, just observe whether independent source connected to the given circuit for the long time or not. If it is connected, and if you are having inductors and capacitors, either inductor or capacitor or maybe combination, first of all you have to find out with respect to inductor means initial current, and similarly with respect to capacitor means initial voltage. Okay, right. So first of all you have to consider the circuit at t equal to 0 minus. At t equal to 0 minus, circuit is in steady state. At t equal to 0 minus, circuit is in steady state. Okay, so here at t equal to 0 minus, switch is open position. Okay, switch is open position, right. Then here you are having capacitor. In steady state, capacitor acts as open circuit. In steady state, capacitor acts as open circuit. So now across the open circuit terminals, definitely you can get the voltage, right? Since we are considering the circuit at t equal 0 minus, accordingly I have mentioned the notation like that, Vc of 0 minus. Okay, right. Now here voltage across these two terminals we have to find out. In this question, this voltage is nothing but voltage across this 4 ohm. That's all. Because this point is same as this one, this point is same as this one. Now here, just if you carefully observe, you are having 6 ampere current source and then 6 ohm resistor, and here in this branch, since current is not flowing because the terminals are open, right? Now these two elements connected in series. That's all. These two elements connected in series. Whatever the current I is flowing, the same current will flow here. Yes or no? That means these two are connected in series. 2 plus 4 is nothing but what? 6. Okay, just for reference here I am mentioning 2 ohm plus 4 ohm. That is nothing but 6 ohm. Okay. Now here what you understood. Here you are having 6 ampere source and here 6 ohm. Here together 6 ohm. All the elements connected in parallel, right? In parallel voltage will be same. Current is getting divided. And here luckily, here 6 ohm and here net resistance is 6 ohm. Since you are having equal resistor, whatever the supply current is there, half of the current is flowing here, remaining current is flowing here, correct? Okay, so that means here I by 6 by 2, that is nothing but 3 ampere is flowing, so here 3 ampere is flowing. See, the moment you have drawn the equivalent circuit like this, in order to find the current or in order to find the voltage, you are bringing the circuit into first chapter. That's all. That's all. Okay, right. Once if you know the basics of first chapter, definitely we can solve. Okay, right. So now you can use Ohm's law. Here current is entering like this. That means voltage polarities you are getting plus here and then minus here. 3 into 4, that is nothing but 12 volts. So across these two terminals voltage is nothing but across this 4 ohm. So Vc of 0 minus is equal to 12 volt. Now the most important thing, here we are performing the switching action at t equal 0. That means at t equal 0 minus and at t equal 0 plus, the capacitor voltage is going to remain the same. Okay, Vc of 0 minus is equal to 12 volt. That is same as Vc of 0 plus. That is the reason, even though in the question they are asking with respect to any parameter, they can ask with respect to resistor or with respect to inductor, with respect to capacitor, they can ask current or they can ask voltage. Irrespective of that, just have a cross check point till just before the switching action, whether in the given circuit, if you are having inductors or if you are having capacitors, and for those elements, whether any independent sources connected or not. If they are connected, definitely you have to draw the equivalent circuit at t equal 0 minus and you have to find out the initial values. And with respect to capacitor, initial voltage is going to be remain same even at t equal 0 plus. This is the most important conclusion point. Okay. Now here the question they are asking in this particular resistor, how much current is flowing at t equal 0 plus. Now you can draw the equivalent circuit at t equal to 0 plus. Okay, at t equal to 0 plus, now we have to draw the equivalent circuit. At t equal to 0 plus, what is the behavior of capacitor? At t equal to 0 plus, what is the behavior of capacitor? Exactly opposite. Earlier it is like open circuit, now it will become short circuit. Okay, but whatever initial voltage here you got, that initial voltage we have to connect. Okay, so here we got 12 volt, that one we have to connect. Okay, right. So initial voltage, whatever you got 12 volt, that one we are connecting. Suppose if initial value is 0, then we will make it as simply short. That's all. Okay, right. So here at t equal 0 plus, switch is in the closed position. At t equal to 0 plus, sorry. Okay, at t equal 0 plus, switch is in the closed position, right? Okay, at t equal 0 plus, switch is in the closed position and capacitor acts as short circuit, and here initial voltage there, that initial voltage we have kept. Okay, next, now you have to find out here in this branch current at t equal 0 plus, that's all. Okay, now if you observe, since the switch is closed here, okay, so this point generally you will be considering ground. So since these two terminals are same, this node voltage also same, 0 volt only, right? Okay, so here this branch and 6 ohm both are connected parallel. In parallel voltage will be same, 0 volt, and by using Ohm's law you are getting 0 ampere. 0 ampere. That means in this branch there is no current flows. Okay, right. Now here just observe. Here you are getting 12 volt. That same 12 volt you are getting across 4 ohm. Okay, right. So that means this node, okay, between this node and ground, because all these points are same only, you can observe closely. Between these 2 points you are having 12 volt. Okay, just for reference here I am mentioning. And since these 2 points are same, here you are having 0 volt. Okay, now you have to apply Ohm's law, that's all. Okay, so I equal to, at t equal 0 plus, okay, at t equal 0 plus, I equal to 0 minus 12 divided by 2. So that means you are getting minus 12 divided by 2, that is nothing but minus 6 ampere. Suppose if they have given current direction like this, then 12 minus 0 divided by 2, that means you are getting 6 ampere. Okay, this is the most important, like based on the direction of the current, you may get positive value or negative value. Okay, right. Yeah, next question, all of you give it, right? So just see this question. Here you are having one circuit, and here switch is open at t equal 0. You can observe here also at t equal 0 we are opening the switch. Okay. Now they are asking, in this question they are asking value of current, value of the current I of t at t tends to infinity. See, whenever they are asking in steady state, no need to bother what is happening at the initial condition. Okay, see, earlier question is what? At t equal to 0 plus they are asking. When they are asking at t equal 0 plus, definitely you have to draw the equivalent circuit at t equal 0 minus. Okay, because from t equal to minus infinity, at t equal 0 minus circuit is already reached to steady state. That is the reason. That is the reason. Okay, now here since in the question they are asking like the current I of t, that means in this particular 20 ohm resistor, how much current is flowing at t equal to infinity. That means once again steady state. So directly you can draw the equivalent circuit at t equal to infinity, that's all. Okay, right. So now you have to draw the equivalent circuit at t equal to infinity. So as per the question, here the switch is opened at t equal to 0. So at t equal to 0 switch opened, that means even at t equal to infinity it is in open position only. That is the first observation point. Okay, so now here we are drawing the equivalent circuit at t equal to infinity. At t equal to infinity means circuit is in steady state. Circuit is in steady state. Okay, right. So here switch is in open position. Okay, in steady state, inductor acts as short circuit. Earlier capacitor having capacitor acts as open circuit. Here inductor acts as short circuit. Okay, so here in this particular, okay, yeah, inductor says short circuit. Now after that, what are the elements here you're having? You can keep as it is. You can keep as it is. And here in this particular branch, okay, you have to find out the current I of t at t equal to infinity. So accordingly, I am substituting here I of infinity. I of infinity. Okay, right. Now see, after you are able to draw like this circuit, now just by observation of this circuit, even though we are solving the questions of 4th chapter, that is transient analysis, but when you look at this question, in order to find out I of infinity, this question is as good as you are solving the 1st chapter question. That's all. That's all. Okay. So that is the reason whatever the questions we are going to cover, okay, we already covered in the yesterday's session and today's session, some of the questions we covered, and some more questions we are continuing here in this particular session. Whatever the models we are covering regarding network theory subject, right from the 1st chapter till the last chapter, whoever practiced these questions, definitely you can get very good marks in the upcoming GATE exam. Okay, and in addition to that, whoever very much prepared earlier, okay, whatever the other models or other questions you might be having in your notes, accordingly you can prepare. But whoever, like with the help of yesterday 3 hours and with the help of today 3 hours, whoever want to get even minimum marks easily, right, with the help of, I can say less effort, but you can, with the help of less effort and less time you are putting, but you are getting decent marks easily. Okay, only thing, you should be fundamentally strong, that's all. Okay, and whoever by this time might have attended the classes, okay, or might be having the classroom notes with you, okay, so you can do, like after attending these 2 sessions, you can have a look at your notes, the kind of perception, the kind of, you know, the way you have to see that particular network theory question, the dimension is going to change. Okay, at least I am going to, like after attending these 2 sessions, you are getting that vision or eye, okay, how to visualize the given circuit, in which domain or in which dimension we have to see the question, so that we can easily solve that question in less time. Okay, right. So all the techniques, wherever required, shortcuts, everything, conclusion points, each and every important note point I am going to cover. Okay, I already covered earlier, even what are the questions currently I am discussing also I am going to cover. Okay, right. Yeah, just observe here. So here you want to, we are supposed to calculate I of infinity. Okay, so if you carefully observe, you can solve this question by using which method? Any guess? Definitely you people can answer. Nodal analysis, that's all. Okay, so here this node voltage you can consider as ground. Okay, this node voltage you can consider as ground. Next, this node voltage you can assume as, say for example, V1. Okay, right. So here in this branch, current is leaving, here current is leaving, here current is leaving. That's all. Sum of all the leaving currents equal to 0. So here, whenever you are having voltage source in series with resistor, if you don't know how to write the current flowing in this particular branch, no issue. You keep 20 ohm here and then 30 volt here. Then definitely you will be writing correct. So here V1 minus 30. V1 minus 30. See, if you are keeping 30 volt this side, okay, then overall net voltage you are having 30 volt with respect to 20 ohm, other terminal I mean to say. On the left hand side you are having V1. V1 minus 30, okay, divide by 20. Then here in this branch, V1 by 20. And here 20 ohm, 20 ohm, both are connected in series. 20 ohm, 20 ohm, both are connected in series. Equivalent resistance is 40 ohm. Okay, V1 by 40 ohm is equal to 0. Right, you can do the simplification. Here V1 by 20 plus V1 by 20, or otherwise from entire equation you can take LCM as 40. Okay, right, or before that you can do in simple calculation point of view, 10 you can take common, or otherwise 20 you can take common. Yeah, just by observation you can take 20 as common in the denominator. So 20 ones, okay, here 20 ones and then here 22s. Yes sir. So whatever 20 you took common, so 1 by 20, that means cross multiplication, 0 into 20 is 0. Okay, so you are getting here, okay, overall LCM is 2. Okay, then here you are getting 2 into V1 minus 30 plus 2V1 plus V1. Yes or no? Okay. Next, 0 into 2 is 0. Okay. So 2V1 plus 2V1, 4V1 plus V1, that is 5V1. Next, minus 60 is equal to 0. 5 12s are 60. So from here you are getting V1 equal to 12 volts. V1 equal to 12 volts. Now here I of infinity we have to calculate. I of infinity is nothing but what? In this branch how much current is flowing, right? That is nothing but V1 by 40. V1 by 40. So that means 12 divided by 40. So 4 3s are 12, 4 10s are 40. So 3 by 10, that is nothing but 0.3. See, in this way, whatever the calculation is there, that calculation also very simple. In the GATE exam, whoever creating the questions, okay, regarding network theory subject, if the exam paper setter is smart, they will give the regarding the component values, okay, in such a way that the calculation part you can do easily without using the calcium, okay. So answer for this question is 0.3 ampere. Yeah, next question, all of you give it a try. This is a very interesting question. All of you give it a try. I am giving 2 minutes time. All of you give it a try. Yeah, here just observe here, across the inductor you are having the voltage, okay, that particular voltage at t equals 0 plus, okay. If you read the question here according to this notation, okay, so dv of 0 plus by dt, okay. Some students will be having the misconception, what they will be doing at t equal to 0 plus, they will be drawing the equivalent circuit. You are getting at t equal 0 plus, inductor acts as what? Open circuit. Definitely you are getting the voltage across it, okay. That voltage value will be what? Constant. So when you are performing the derivative, definitely you are getting 0. But okay, that concept is okay, might be okay with respect to maths or any other subject. But coming to the network theory subject, that way of solving is not at all correct, okay, because definitely here, like whatever the like differentiation they are asking, either with respect to first order or second order, okay, in majority of the cases or majority of the questions I can say, definitely you will be getting other than 0, other than 0. But here how to see this particular question, even though if they are asking like that, it is very simple, okay. So here when you read this question, you are having differentiation of voltage across the inductor, correct? So first of all, when you're having the inductor, okay, with respect to inductor, you can find the current for generalized case. Okay, after that, just use the Ohm's law. Voltage across inductor is what? L into d by dt. L into d by dt. From there, you are getting voltage across inductor. Okay, after that, that voltage across inductor, you have to consider what? Derivative. Okay, like that you can perform the differentiation. After that, you can consider. After that, you can consider what? At t equals 0 plus instant. Okay, that is the most important. Okay, right. So here, just by observing the circuit, here we are giving what? U of t. U of t means what? The signal exists from time 0 instant onwards, right? So that means from t equal to 0 instant onwards, we are giving 2 ampere current. That means up to t equal 0 minus. This u of t value up to t equal 0 minus, the value is 0. That means current source value 0. That means it is an open circuit. If it is an open circuit, for this resistor inductors combination, whatever the network you are having, for this network, there is no independent source connected, right? If there is no independent source connected up to t equal 0 minus, definitely IL of 0 minus. At t equal 0 minus, the initial current is what? 0, and the same current will remain even at t equal 0 plus. Okay, right. So just directly I am writing at t equal to, okay, I am directly writing here, IL of 0 minus is equal to 0 ampere, that is same as IL of 0 plus, and that one, if you want, you can consider as generalized case IL of 0. IL of 0 means initial value, initial current. Okay, right. Now coming to the steady state at t equal to infinity. At t equal to infinity, here inductor acts as what? Short circuit. Okay, inductor acts as short circuit, right? So the moment here short circuit, so here 8 ohm, across 8 ohm you are getting what? 0 volt, and by using Ohm's law, here 0 ampere. That means in this 8 ohm resistor, there is no current flowing, right? In this 8 ohm resistor, there is no current flowing. At t equal to 0 instant onwards, even at t up to t equal to infinity, u of t value is going to be 1, and here multiplication factor is 2. So that means 2 ampere is present even up to t equal to infinity. That means the entire 2 ampere is flowing through the inductor. So you are getting one closed circuit like this. Okay, right. So IL of infinity equal to 2 ampere. I hope all of you understood how we are able to get initial current and then final current. Now, I hope all of you know the generalized formula, like when you are having in terms of initial and final, like IL of infinity minus of IL of infinity minus IL of 0 into e power minus t by tau. Okay, whenever you are having initial current is 0 and only final current is there, that time after you are substituting in that equation, from there you are getting the current flowing through the inductor in the simplified form like this. Okay, IL of infinity into 1 minus e power minus t by tau. I hope all of you aware these formulas, right? Okay, IL of infinity into 1 minus e power minus t by tau when initial current is 0. Okay, now you can substitute here IL of infinity we got 2 into, okay, so before represent that one, okay, just for reference I am writing. Okay, here in this entire equation IL of infinity we calculated. Now tau value how to calculate? Tau is nothing but L equivalent by R equivalent, right? Here in this part of circuit only one inductor is there, definitely that is L equivalent, that is 1 Henry, okay, divided by. So after removing the inductor here, then terminals become open. Across the open circuit terminals you have to find the equivalent resistance, right? Here current source is there, you can make it open. You are getting across this open circuit terminals you are getting 8 ohm, right? So 1 by 8. So you are getting tau equal to 1 by 8. Okay, units are seconds. So now you can substitute. Okay, IL of infinity you got, tau value you got. Now you can substitute in this expression. So IL of t equal to IL of infinity, that is 2 ampere into 1 minus e power minus t by tau. Here tau value is 1 by 8, that means 1 by tau, 1 by 1 by 8 is nothing but 8. So directly I am representing 8. Okay, for t greater than or equal to 0. Okay, I hope it is clear for everyone up to this step. Now, here in this question, you are supposed to find out dV of That means differentiation with respect to T regarding the voltage across inductor, right? So first of all, you can write voltage across inductor formula. Voltage across inductor VL of T, but in this question they have mentioned like V. Okay, suppose I am representing in this order, like VL of T equal to L into d by dt. L into d by dt. Okay, suppose in the same question, suppose with respect to the current flowing through the inductor derivation, okay, then what is the equation here you got? You can perform the derivative. Okay, but here they are asking voltage across it, that is VL of T equal to L into d by dt. So here L value is 1 and derivative of this entire expression. Okay, derivative of this entire expression. So what you are getting? 2 into derivative of constant 1, that is 0. Derivative of 1 is 0. Okay. Next, minus e power minus 8t derivative, e power minus 8t, and minus 8t derivative, you are getting minus 8. Okay, right. So from here what you are getting? Minus of, see, 0 minus of minus 8 into e power minus 8t. Okay, so minus of minus is plus, 2 8s are 16 into e power minus 8t. Okay, now this is your voltage across inductor, but now they are asking what? Derivative of this voltage, right? Just perform the derivative, dVL of T by dt, dVL of T by dt. Okay, here 16 anyway constant, right? Now e power minus 8t derivative, you are getting e power minus 8t into minus 8t derivative, you are getting minus 8. So this is the differentiation of voltage with respect to time, right? But now what they are asking? So whatever the derivative we have done, now in this particular equation, now you can substitute t equal to 0 plus. That is the beauty of the question, right? Now you can substitute at t equal to 0 plus. At t equal to 0 plus, this value is going to be 16 into minus 8 into e power 0 is nothing but what? 1. E power 0 is nothing but 1. So 16 into minus 8. So that means here you are getting minus 128. Minus 128. Here units will be very simple. Numerator you are having what? Voltage. Denominator you are having time, seconds. That's all. Minus 128 volt per second. That is there in option A. So answer for this question is option A. In this way we have to solve. See, whenever you are having exponential form like time domain expression, okay, when you are having, you can perform any number of times derivative, definitely you are getting in terms of exponential only. Yes or no? That is the reason. That is the reason, like at t equal 0 plus, when you are substituting, e power 0 value is going to be 1, but because of whatever the scaling factor you are getting, accordingly you are getting. That is the reason, as I mentioned earlier, you should not do that kind of silly mistake. Okay. Whatever I have addressed at the beginning of this particular question. Okay, I hope it is clear for everyone, right? Yeah, see, since the context came, I am giving one more like way to solve another question. Like suppose here, with respect to current flowing through the inductor derivative, if they ask, okay, then like this expression you can write and then you can perform the derivative. That is one approach. And one more approach what you can do, like whatever the circuit you are having, like first you can consider at t equal to 0 plus, okay, try to find out the voltage across the inductor, that is V of 0 plus you are getting. Okay, the basic relation is this one, voltage across inductor is L into d by dt. So dA by dt they are asking, that means voltage across inductor divided by L at t equal 0 plus. Okay, at t equal 0 plus find the voltage across inductor, divide with inductance. From there also you are getting this one approach, and what are the equation here you are getting, there also you can perform the differentiation and then you can put t equal 0. Okay, t equal 0 plus, accordingly same answer you will be going to get. Okay, that is also one more approach. Fine. Yeah, next question, all of you give a try. This is a dead easy question if you are able to apply Laplace transform. See, first of all, read the question. Here you are having the current through a series RL circuit. Okay, you are having series RL circuit. Okay, in that series RL circuit, the current flowing is e power minus t units are ampere. Okay, e power minus t units, if you want, you can consider ampere. Yeah, thank you, Abhishek. Right, e power minus t ampere. When the circuit is excited, excited means what? Input we are giving. Here input we are giving for this particular circuit as unit impulse voltage. That means you are having one series RL circuit, resistor is there, inductor is there, both are continuous series. For that series RL circuit, we have given input voltage, exit response we are getting current. Okay. Yeah, very good, Abhishek, very good. Yeah. So here voltage is the input, current is the output. Now in this question they are asking the values of resistor and inductor. Okay, right. So since you are having here impulse voltage and response is current, okay, e power minus t, whenever you are getting such kind of questions, okay, wherever you are facing the difficulty in the time domain with the help of time domain approach regarding transients chapter, okay, see whichever questions you are very much comfortable with the help of time domain, you can do it. In whichever questions you are facing the difficulty with respect to time domain analysis, all those questions you can convert the given circuit into S domain by applying Laplace transform approach. Okay, if you apply Laplace transform approach, you are getting one equation in terms of S domain. After that you can do the simplification by using partial fraction, and then if you apply inverse Laplace transform, from there you can find the time domain response. Okay, but in this question they are not asking, okay, regarding input and output they have given in time domain only, but here in the circuit whatever the resistor and inductor you are having, regarding that they are asking the values, that's all. Okay, so I hope all of you know, whenever you are having simple Ohm's law, right, for any circuit you can write Ohm's law, voltage equal to current into impedance, that's all. So in terms of S domain I am writing V of S equal to Z of S into I of S. Okay, right. So here V of S, voltage you are having what? Unit impulse. Whenever you are having unit impulse signal, Laplace transform you are getting what? 1. Laplace transform of impulse signal is 1. Okay. Next, here impedance, resistor and inductor both are continuous series. In series we can add the corresponding impedances like R, regarding resistor R, regarding inductor impedance is SL. Okay. Coming to the I of S, here current you are having e power minus t, apply Laplace transform. Laplace transform of e power minus t is nothing but 1 by s plus 1. 1 by s plus 1. Okay, right. Now, just you can do the like cross multiplication. From here you are getting s plus 1 is equal to r plus sl. Okay, r plus sl for the timing I am writing like sl plus r. Okay, just compare here. From here what you are getting? R value as 1 ohm. And L value also 1 Henry. Yes, sir. SL, but here S into 1. That means L value is 1. Similarly, R value is 1. Okay. So you are having R value 1 ohm, option A, L value 1 Henry, option B. This question is MSQ. 2 correct options are there. Okay. In this way, you can solve regarding transients. Especially earlier, some student asked regarding like second order circuits. See, second order means what? You are having both inductor and capacitor. Okay, when you are having both inductor and capacitor, in the time domain if you want to solve the question, especially in order to find the time constant, it is very difficult because you are getting like with respect to RL circuit, you can find the time, like you are finding equivalent inductance, after that you are removing the inductor, then terminals become open, across the open circuit terminals you are finding the resistor. Similarly, RC circuit. But when you are having the combination of R, L and C, that time directly from the given circuit you cannot calculate the time constant. That time, like that questions, wherever you are facing a difficulty, you can apply the Laplace transform approach and you can solve the question in the S domain, and finally you can convert by applying inverse Laplace domain. You are getting time domain expression. From that time domain expression you can represent in the standard form. Okay, just like here when you are having regarding the current, I final. Okay, here since initial current is 0, accordingly you are getting. Okay, so just I am giving the hint, whichever exponential term you are getting, like e power minus t by tau format. Okay, like this format you can represent. So for the second order system, you are getting 2 time constant. That means like this exponential terms you will be getting 2. Okay, e power minus t by tau 1, another term e power minus t by tau 2. Okay, from there you can find the time constant. That's all. Okay, I hope it is clear for Hemant. Okay, right. Yeah, next question. All of you give it a try. This is a very interesting question. All of you give it a try. I am giving 2 minutes time. All of you give it a try. Abhishek, in the previous session, we have discussed 17 questions, right? So out of 17 questions, for how many questions you got correct? Yeah, this is a very interesting question. I have mentioned it is an excellent question. Okay, you will come to know while you are solving the question why I mentioned this is an excellent question. Okay, so just observe here in this question, you are supposed to find the peak current that is flowing through resistor. Here you are having one resistor. In this particular resistor, how much maximum value of the current that is flowing in this particular resistor, that you have to calculate. Okay, now see the beauty of this question. Here you are having AC supply. That means whatever the questions so far we have discussed up to here, like we have covered up to transients, now we are going to solve the questions regarding steady state. Okay, that is the last chapter. Okay, regarding network theory subject. So here you are having AC voltage source and then resistor, inductor, capacitor, resistor, inductor, capacitor. Okay, whenever you are having AC circuit, okay, definitely whatever the inductor and capacitors you are having, regarding that you can represent impedance values. Okay, after that you can find the equivalent circuit impedance and all. In that manner you can do the simplification. Like in the first chapter we have discussed multiple resistors are present in the given circuit. There we have find the equivalent resistance. Like that we have found equivalent inductance, similarly equivalent capacitance. But when you are having combination of resistor inductor or resistor capacitor or inductor capacitor or combination of RLC, that time you can use impedance term. That's all. Okay, right. So whatever the given circuit is there, from here if you observe sin omega t format, that means from here you are getting omega value is how much? From here your observation, omega value we are getting 1. Units are radian per second. If you want you can write, or otherwise it is optional. Okay, 1 radian per second. Okay, omega value is 1. Okay, Next, wherever resistance values are there, you can keep as it is, because resistance value, the impedance of the resistor, both are going to remain same. Okay, so here 2 ohm, here 4 ohm as it is. Now first I am representing regarding inductor impedance, that is nothing but j omega L. Okay, see, just like here we have mentioned, like when you are having inductor SL, where S is nothing but what? J omega. That means j omega L is nothing but impedance of the inductor. Okay, so j omega L, here omega value is 1, omega value is 1 into L, L value is 25. J 1 into 25, that means J 25, here units are ohms only. Ohms only. Reactance or impedance units are ohms only. Okay, right. Next, similarly here you are having inductor. Okay, for the timing I am doing the simplification here. 2 5s are 10, 2 3s are 6. Okay, so j omega L, omega value already 1 into L, L value is 5 by 3. So direct step I am writing j 5 by 3 units are ohm. Next, regarding capacitor. Regarding capacitor, you are having Zc equal to 1 by j omega c. Okay, just for reference I am mentioning here. Zc equal to 1 by j omega c. This 1 by j you can write as minus j. Okay, minus j divided by omega c, or minus j into 1 by omega c, your wish. Okay, right. So here I am representing regarding this capacitor, minus j divided by omega value anyway 1 into c. C value is 0.04. For the timing I am writing it as 4 by 100. 4 by 100. That means here this, okay, 4 here 25 times. That means this 25 will go into the numerator. So from here you are getting minus j 25 ohm. Minus j 25 ohm. Okay. Next, this capacitor. Here also we can do simplification. 3 3s are 9, 3 5s are 15. Same logic. Minus j divided by omega c. Okay, minus j divided by omega c. Omega value is 1. Okay, into c value is 3 by 5. Now this one we can represent as minus j into 5 by 3. Units are ohm. See, here for understanding purpose I have represented each and everything, but the magic or the most interesting thing you are getting from here. Okay, see, just observe, tell me what is the, here inductor and capacitor both are contained in series. In series we can add the respective impedances. Here j5 by 3, here minus j5 by 3. That means after you are performing the equivalent inductance here, what you are going to get? 0 ohm, that's all. That is the magic here it is happening. 0 ohm. See, 0 ohm is what? It is a short circuit. It is a short circuit. Here you are having inductor, capacitor, resistor and this branch. All are contained parallel. Okay. See, whatever might be here, you might be getting. Okay, whatever might be getting equivalent inductance. Okay, something you are getting finite. Okay. Now that overall equivalent impedance is in parallel with 0 ohm. That means it is very simple. Let us consider this overall equivalent impedance something like Z1. Now Z1, Z2 divided by Z1 plus Z2. So 0 into Z1 is 0 divided by Z1 plus 0. That is 0 by Z1 you are getting. That means this overall network impedance you are going to get 0 ohm. That's all. Okay. Here you might be getting something I am representing like Z1, or otherwise you can consider ZA, your wish. Any notation you can consider. Okay, for the timing I have considered Z1. Now this overall configuration impedance is Z1, that is in parallel with 0 ohm. Net equivalent impedance you are getting 0 ohm. See the beauty of this question. It is looking like very complicated network, but because of this branch impedance is 0 ohm, this entire equivalent circuit you can replace as one short circuit. That's all. That means the moment here overall circuit is short, now whatever supply voltage you are having, that entire supply voltage you are getting across the resistor. That's all, across the resistor. Okay, right. So here like voltage across resistor, in this question you are getting 20 sin t. Okay. So in this particular resistor, okay, if you want, you can assume the current direction like this. Okay. Now you can just use Ohm's law, current into resistance. Resistance value in this question it is 2, that is equal to 20 sin t. So from here you are getting I value as 10 sin t. I equal to 10 sin t. That's all. Okay, this is the current that is flowing through this particular resistor. Okay, now the question, in the question you are supposed to calculate only maximum current. Peak current or maximum both are same. That means answer for this question is 10. Maximum current or peak current both are same. Right? Whenever you are having sine or cos, maximum value is what? +1. +1 here into here in this example 10 is there. Definitely it is a 10. Okay. Right. Yeah, next question, all of you give it a try. Yeah, Abhishek, I hope you might have got most of the questions correct. Okay. From the previous session. Yeah, just observe here, just observe. In this question, you are having 4 ampere source, that is a DC source. Here 5 cos 0.2 t volt, that is a voltage source, but that is a AC source. Whenever you are having combination of AC source and DC source, definitely you can solve that question by using superposition theorem. Okay, right. So here in this question they are asking maximum current that is flowing through 20 ohm resistor. Here you are having 20 ohm resistor. So in that particular 20 ohm resistor, what is the maximum current that is flowing? Okay. Right. So we can solve this question by using superposition theorem. Right. Okay. So first of all, consider case 1. That means I am considering only the current source 4 ampere. Okay. In case 1, I am considering 4 ampere. That means this particular voltage source we have to replace as short circuit. In case 1, we have to replace this one as short. Okay, right. That is the first step. And whenever you are having DC source, time period is infinite. That means frequency will be 0 hertz. DC signal means what? 0 hertz. Okay, frequency is 0. So since you are getting frequency 0, regarding the inductor, impedance is what? J omega L. Omega value is nothing but 2 pi f. That value is 0. Okay, that means here inductor become short circuit. For DC circuit, inductor become short. J omega L, that is nothing but 0. Okay, right. Now here if you observe, the moment you got here short, that means here you are having 0 volt. Across 20 ohm also, same voltage you are having. So definitely you are getting, by using Ohm's law, 0 ampere. That means for DC circuit, okay, when you have considered 4 ampere source, the current flowing through 20 ohm resistor is 0 ampere. Okay. So in case 1, we got I1 equal to 0 ampere. The current flowing through 20 ohm, for the timing I have labeled as I suffix 1, case 1. Okay. Now let us solve in case 2. So here we are considering what? AC source. Okay. Now this current source we have to deactivate. Since it is a current source, okay, we have to replace as open circuit. Okay. Now coming to the inductor, j omega L, omega value is 0.2 and inductance value in this question you are having 50 Henry, j omega L. Okay. So here 50 into 0.2, that means you are getting j 10 ohm, j 10 ohm. Yes or no? 52 sir 100. After that you have to place the radix point after one place, so that means you are getting j 10. Okay, right. Next here you are having 10 ohm, 10 ohm and then 20 ohm, 5 ohm. Okay. Since in this branch there is no current flows, that means these two elements connected in series. Okay, 10 plus 10, that is nothing but 20 ohm. Okay, right. Next, here also 20 ohm, and here just observe between these 2 points. Okay, with respect to these 2 points, you are having 20 ohm resistor, then inductor, and then 20 ohm. All are connected in parallel only, right? So with respect to this 20 ohm, and this 20 ohm, parallel connection you are getting 10 ohm. Okay, 20 parallel to 20, that is 10 ohm. Okay, now just closely observe. You are having supply voltage, then one resistor 5 ohm, and then here equivalent resistance you got 10 ohm, and then j 10 ohm. Okay, 10 ohm, j 10 ohm, both are contained in parallel. In parallel, definitely voltage will be same. Okay, in parallel voltage will be same. That means across 10 ohm resistor voltage is same as across this 20 ohm and across this 20 ohm. All are same only because the terminals are going to remain same. Okay, I hope all of you are getting clarity. Just for reference, here I am mentioning like this node voltage, like since we are solving in case 2, I am labeling as V2, suppose. Okay, V2 with respect to ground. Now what you can do? You can apply voltage division rule. V2 equal to supply voltage, that is 5 cos 0.2t. Now here it is very simple. See, numerator what you have to do? Across which branch you want, that branch impedance you have to consider. Okay. So here, yeah, before applying voltage division rule, I am just writing here. Okay. Yeah, Z2 I am writing just for reference. Z2 is nothing but this overall equivalent impedance. That is Z2. Okay, that one here I am labeling. Here as of now we got 20 parallel to 20, that is 10. Okay, now that 10 in parallel with J10. 10 parallel with J10. So that is nothing but 10 into J10. It is like Z1 Z2 divided by Z1 plus Z2. Okay, you can take 10 as common. Numerator, denominator, 10 will get cancelled. After that you are having J10 divided by 1 plus J. Multiply and divide with 1 minus J. Sorry. Yeah, multiply and divide with 1 minus J. So here 1 plus J into 1 minus J. So in general you will be getting A plus B into A minus B as A square minus B square, like that. Here 1 into 1 is 1. Okay, but minus B square. Here B is nothing but J square is nothing but minus 1. So that means denominator you are getting 2. 2 here 5 times. Okay, so direct step I am writing like 5. Okay, one more step I will write, no problem. 10 divided by 2 you are getting, and numerator you are having J minus J square. J square is nothing but minus 1. Now from here you are getting 5J plus 5. 5J plus 5 or 5 into 1 plus J, your wish. 5 into 1 plus J. Five into 1 plus J. So this is the overall equivalent impedance here. Now you can see supply voltage there, here one resistor and here one impedance. You can apply voltage division rule in order to find this voltage. Okay. See here voltage means you can consider with respect to this resistor or with respect to this or with respect to this or even with respect to equivalent. Okay. I hope all of you got the clarity. With respect to this one or with respect to this one or even with respect to this one or overall equivalent. Okay. Now in order to find out the voltage across this one, you can easily apply current division, voltage division rule. Voltage division rule, if you are applying, from there you are getting V2 equal to 5 cos 0.2t, 5 cos 0.2t into numerator across which branch you want the impedance, that will come. That means here overall equivalent impedance we got. Overall equivalent impedance we got 5 into 1 plus j. 5 into 1 plus j. Divide by sum of the impedances. 5 into 1 plus j. 5 into 1 plus j plus 5 plus 5. Okay. Now here you can take from numerator and denominator 5 as common, 5 will get cancelled. Okay. After that you are having 5 cos 0.2t into 1 plus j divided by, direct step I am writing 1 plus j plus 1, that means 2 plus j. 2 plus j. Okay. Now you can represent magnitude form and phase angle. So 5 into here root 1 plus a square plus b square format. So 1 plus 1, that is 2. Okay, 1 square plus 1 square, that is 2. Dash step I am writing. Okay, denominator you are having root 2 square, that is 4 plus 1. And phase angle wise you will be getting, okay, for the timing I will keep as it is. After that next step I will write. Okay, just 1 second. Yeah, 5 into 1 plus j divided by 2 plus j into cos 0.2t. This is the voltage we are getting across this overall impedance. Okay, and that voltage is same as across this 20 ohm, that same voltage across this impedance across this particular overall 20 ohm. Correct? Okay. Now here we have to find out the current flowing in this particular branch, that is 20 ohm. So in this case I am labeling as I2. I2. Okay. So just consider here I2 equal to V2 divided by 20. V2 divided by 20. So here 5 divided by 20, that is nothing but 1 by 4. 1 by 4 into 1 plus j divided by 2 plus j. 2 plus j into cos 0.2t. See, from this equation, if you do further simplification, you can write the magnitude and then write the phase angle. That phase angle you can add here. Okay, right. So here in this question, if you observe, you are supposed to find out the maximum current that is flowing through 20 ohm resistor. Okay, in already case 1 we got 0 ampere. With respect to case 2, just like earlier question, you can observe earlier question, maximum current across the maximum current that is flowing through the resistor. So here when you are having sine or cos, whatever the peak amplitude here you are having, that one only 10. Okay, like that here in this question, whatever here you are having, from here you can consider magnitude. Okay, that from that magnitude whatever you are getting, that itself is the peak value, that's all, or max value you can say. Okay, so here I am writing I2 max. Okay, max value of I2 max is equal to 1 by 4 into magnitude of this one, so square root of 1 plus 1 divided by square root of 4 plus 1. So 1 by 4 into root 2 divided by root 5. Okay, you can do the simplification here. 1 by 4 into root 2 divided by root 5. Yeah, after doing the simplification, here you will be getting 0.158. 0.158 units are ampere. So by using superposition theorem, so here the maximum current that is flowing through the resistor 20 ohm. In case 1 we got 0, in case 2 we are getting 0.158. So from here overall answer is 0.158 units are ampere. I hope it is clear for everyone. See, whenever you are having any LTI system, for that LTI system, if you are having input as sine, output definitely you are getting sine. Similarly, if you are giving cos, output you are getting cos. Okay, but only the magnitude and phase angle is going to change. Okay, so these kind of questions, whatever the procedure you might have learned, like in the signal system or control system or network theory subject. So one approach you are having, you have to find out the transfer function. For the transfer function, in place of s you can put j omega. After that you can consider the magnitude and then you can consider phase angle. Whatever the magnitude you are getting, that magnitude you can multiply with the input signal magnitude. Similarly, whatever the phase angle you are getting, you can add with the phase angle of the corresponding input. So accordingly you are getting at the output. Okay, that is one approach. Okay, because you are familiar about that approach, I have solved this question in another approach. Okay, so in this manner, whichever methods you are comfortable, accordingly you can go ahead. Okay, right. Yeah, next question, very interesting one. All of you give it try. Yeah, just observe this question. Here you are having one network. Okay, right. So just in order to get maximum power across the load, that load where we are connecting, where we are supposed to connect. Here we are supposed to connect the load across. The load we are connecting between the terminals A and B. Here you are having the terminus A and B. With respect between the terminus A and B, we will be connecting the load impedance. Okay, so there across that particular load impedance, you should get the maximum power. Okay, in order to get like that. Okay, so regarding that particular load impedance, that means what are the combination of elements. Okay, so that we have to find out. That's all. So for that you are having choices. You can observe you are having resistor in series with resistor in series with capacitor, or resistor in series with inductor, or parallel combination of resistor and capacitor, or parallel combination of resistor and inductor. Okay, so before deciding here among these four choices which one is correct, very simple, like here already we have solved similar kind of question with respect to DC circuit. Okay, with respect to DC circuit, what we have told, if you are having the load resistor here RL, if you want to get maximum power across it, RL equal to RTH, right? Now here with respect to AC circuit, when we are having like AC supply and then multiple, like you are having resistors, everything like this. Okay, and here you are having resistors and then capacitor also. Okay, right. So when you you have to find out equivalent impedance here with respect to the terminus A and B. Okay, ZTH you are getting. Similarly, Now what will be the condition? ZL equal to ZTH conjugate, that's all. ZL equal to ZTH conjugate. So first of all, you have to find out with respect to terminals A and B, ZTH. That is the first and foremost. We have to find out the equivalent impedance. Okay, right. Next, here you are having, in order to find out the equivalent impedance, voltage source we have to replace as short. Voltage source we will be replacing as short. Then current source we will be replacing as open circuit. Open circuit. Right, that's all. Here 10 ohm, here 10 ohm. Okay. Then here you are having minus J5. Okay. Here already they have given the impedance. Already they have given the impedance. Okay. Right. Just observe here, this 10 ohm and 10 ohm both are contained in parallel. This 10 ohm and 10 ohm both are contained in parallel. Equivalent resistance you are getting 5 ohm. 10 parallel with 10, that is nothing but 5 ohm. Yes sir. Right. Now this 5 ohm is in parallel with minus J5. That's all. Actually from here only you are getting the clue. Okay, but just for understanding purpose, let us solve further. But here only you are getting the clue. The moment you got the equivalent circuit like this, from here only you can identify the answer, or at least you can eliminate the wrong choices. Okay, the moment you got like this, at least you can eliminate the wrong choices. So from here what you are getting, ZTH equal to 5 ohm in parallel with minus J5. So that means Z1 Z2 divided by Z1 plus Z2. So here 5 you can take common. Okay, so 5 is getting cancelled. You are having numerator minus J5 divided by 1 minus J. Okay, multiply and divide with 1 plus J. So here denominator we already discussed, a square plus b square format you are getting. That means 1 plus 1 is 2. And numerator just multiply. Okay, minus J5 plus of minus, that is minus J square is nothing but minus. Minus of minus is plus 5 you are getting. So from here what you are getting, 5 by 2, that is 2.5. Then minus J 5 by 2, that means minus J 2.5. That means what you are getting here, ZL equal to 2.5 minus J 2.5. This is ZTH. This is ZTH. Now ZL is what? ZL equal to ZTH conjugate, complex conjugate of source impedance, right? So that means here you will be getting 2.5 plus J 2.5. That's all. See, when you're having the like this format, it is very simple. Just by observation here. Here you are having two impedances. That two impedances you are performing addition operation. That means the elements are contained in series. That's all. Okay, yes or no? The elements are contained in series. So here R value is 2.5 ohm, and coming to the inductor, the corresponding reactance, that is XL equal to 2.5 ohm. Okay, I hope all of you are getting clarity. Here you are having resistor in series with inductor. Resistor in series with inductor. Okay. So just see the options. Resistor in series with inductor. So 2.5 ohm resistor in series with inductor having reactance of 2.5. Yes, it is there in option B. That's why I told earlier, the moment you are getting like this, okay, the moment you are getting like this, that what is your observation? Just closely observe here. Here for understanding purpose we have discussed completely. The moment you drawn the circuit equivalent part like this, here you are getting what? One resistor in parallel with capacitor. That means when you are applying complex conjugate, you will be getting resistor in series with inductor. That's all. Yes or no? That is a clue. Okay, that is the reason I told here, the moment you got like this, okay, with the help of this equivalent impedance, when you are supposed to calculate, because ZL is conjugate, so if you are getting here minus sign, there plus, or if you are getting plus sign here, there minus, like that. Okay. Here it is like parallel, there it will be like series, or here it is series, there it will be like parallel, like that. Okay. I hope it is clear for everyone. Now all of you give a try the next question. Yes, just observe the previous circuit and this circuit. In the previous circuit, they have mentioned here we have to connect one load impedance, right? Load impedance they have mentioned, okay. But in this question, they have given purely resistor, okay. Load contains only resistor. That means reactance is what? 0. Okay, this is a special case, okay. This special case with respect to AC circuit in order to get maximum power across the load resistor. Okay, I hope all of you know the condition in order to get maximum power across the load resistor. Okay, right. So, what is that condition? RL equal to magnitude of ZTH, that's all. See, earlier case, that is a generalized case, ZL equal to ZTH conjugate. But whenever you are having load resistor, purely resistor, but here internal impedance of the source, if you are having like both real part and then imaginary part, that time in order to get maximum power across the load resistor, the condition is RL equal to the magnitude of internal impedance of the source, that is nothing but ZTH. Okay, right. So first of all, we have to calculate with respect to, see, whatever the load resistor you are having, just remove from the circuit, then terminals will become open. Across the open circuit terminals, you have to find the ZTH first and foremost. Okay, in order to find the ZTH, here you are having voltage source, you can make it as short. Okay, right. See, the moment you have shorted, here these two elements connected in series, okay, and then this branch is connected in parallel with this particular branch, that's all. Just you can perform equivalent impedance in order to find the ZTH, that's all. Okay, so here I am writing ZTH equal to 200 plus 100J, that is this branch impedance. Okay, now that branch and this branch both are connected in parallel, Z1 Z2 by Z1 plus Z2. Okay, so here plus term and minus term both are getting cancelled. Okay, after that here 100 is there, here 100 will get cancelled. Okay, okay, or otherwise, okay, I will do one more step, no problem. So as of now I am cancelling 100 100, then here you are having 200 plus, okay, yeah, from here I am taking 100 common, 100 I am taking common, okay, then here numerator you are having 2 plus j, okay, then here minus 100j I am keeping as it is for the time being, right, then denominator you are having 200. Now 100 here 2 times, okay. Now you can do further simplification, yeah, 2 here 50 times, okay, right. Next you can do further simplification, ZTH equal to, yeah, 2 50s are 100 and then you are having minus j, so minus 100j, okay. Next, plus of minus is minus, j into j is nothing but j square, that is nothing but minus 1, okay. So minus of minus plus, so you are getting 50. So from here I am representing like this, 50 minus 100j, okay, or you can take 50 as common, you are having 1 minus j2, 1 minus j2, this is ZTH. But here we have to find out RL. RL is nothing but magnitude of this component, that's all. So 50 magnitude, anyway 50 only, and then here square root of a square plus b square. So 1 square plus 2 square, that is 4. So you are getting 50 into root 5. Root 5 will be 2.23 something. So you will be getting final answer as 111.8. 111.8. See, if it is root 4, that is 2, 52s are 100. Okay. If it is root 9, 3, 350s are 150. But it is closer to 4. Okay, root 4. and then root 5. Okay, 2.23 something you are having. So 2.3 if you consider, okay, 50 into 2.3, accordingly you will be getting like this. Okay, closer to like this. Okay, you can use calci and then you can round off. Then you will be getting 111.8 units are ohms. Units are ohms. See, in this way, wherever required, without using pen and paper, you can try to solve or you can try to do the simplification. So definitely like this logic, it will help you. It will help you. Even though really calculate required, but try to do up to whatever step without using calci. So that this kind of ability, if you are enhancing or if you are putting in the practice, definitely if you solve good number of questions, whatever the calculation part is there, that you can do in the mind level. Here for understanding purpose, okay, I am writing each and everything, but whatever the calculation is there, you can do in the mind level. After that, wherever required, definitely you can use the calcium. Okay, right. Yeah, this is the last question regarding our network theory subject. All of you give it try. This is a question based on resonance. Okay, regarding parallel resonance circuit, all of you give it try. Yeah, this is a direct question. Whoever knows the formula, they can easily solve this question. Okay, so in this question you are having RLC circuit, but this is a parallel circuit, parallel RLC circuit at resonance. That means parallel resonance circuit, simple. Okay, so they have given resistor value, inductor value and capacitor value. They are asking quality factor. See, with respect to series RLC circuit, generalized formula. See, if you are forgetting the formula, how to remember regarding quality factor, it is very simple. With respect to series RL circuit, reactance of any one element like inductor or capacitor, that one divided by R. Okay, so reactance of inductor is what? Omega L. So omega naught L by R, or XL divided by R. Similarly, XC divided by R. And whenever you are supposed to find out quality factor by using RLC, then that time whatever XL or whatever XC you are having, there you are getting, suppose XL is nothing but omega naught into L, or XC is nothing but 1 by omega naught into C. Omega naught is nothing but 1 by root LC. You can substitute and do the simplification. From there you are getting in terms of R, L and C. Whatever the formulas you got for quality factor in series RLC circuit resonance, exactly right hand side whatever the expression you got, just do the reciprocal. That's all. Just do the reciprocal. That is the applicable for quality factor with respect to parallel RLC. That's all. Okay. So when you are having R, L and C with respect to series resonance circuit, you got like 1 by R into root L by C. Now that one you have to make it volta. That means R into root C by L. That's all. Okay. So quality factor in parallel RLC circuit is nothing but R into root C by L. R into root C by L. For series resonance circuit, you are getting 1 by R into root L by C. That one you just do volta. Okay. Reciprocal. r into root c by L. Now you can substitute the values. R value is 2K, 2 into 1000, then capacitor value 5.4 micro, that is 10 power minus 6. Okay. Next, L value is 240 milli. Milli means 10 power minus 3. Okay. You can do the simplification of this one. Final answer you will be getting like 9.486. 9.486. So this one you can approximate to 9.5. So that is there in option A. Option A. So for this question, option A is the correct answer. Option A is the correct answer. Okay, right. So with this, we have covered in yesterday class and today class all together, right? Regarding network theory subject, in yesterday session and today's session together we have discussed total 34 questions. If you remember, in the yesterday class I have discussed 17 questions and 18th question I have given as a homework. That 18th question I have covered in this session, right? So in the earlier session 17 questions and in this session 17 questions together we have discussed 34 questions regarding network theory subject. This is a great number regarding network theory subject, because wherever possibility is there, I have discussed the conventional approach and even easiest method, and wherever important conclusion points are there, that also I have covered. And not but not the least, with respect to GATE exam point of view, from first chapter to last chapter, whichever basics are there or whichever important models are there, in order to cover each and everything, whatever the questions I have covered, I have framed in such a manner. Okay, so whoever attended this particular sessions both yesterday and today in live, those students might have got maximum benefit because you people attended in the live, and whoever watched either yesterday session and this session, whoever watched in the recorded manner also, those students also getting equal benefit. There is no doubt. Okay, because whatever the session here it went, it is in the live session, right? So whoever in general, whichever student at whatever place they might be getting the doubt regarding any concept or any formula, I have addressed, I have clarified each and every doubt. That is the reason, okay, each and every student, whoever attended in the live session and whoever watched these sessions in the recorded manner, each and every student definitely will get maximum benefit regarding network theory subject with the help of yesterday's session and today's session as well, right? So all of you can mention your experience in the comment section, and before mentioning your experience, you people can mention out of 34 questions, for how many questions you people got correct. Okay, you can mention the chart. So I will appreciate all those students whoever got maximum number of questions correctly, and whoever able to try maximum number of questions in order to attempt also, I will appreciate them. Okay, in the comment section. Whoever watching this party session later, you people can mention the comment section, and whoever watching currently in the live session, you people can mention like out of 34 questions, for how many questions you got correct, you can mention the chart. Okay, right. So for the time being, so whoever attended regarding network theory subject, regarding GATE score booster live sessions either yesterday or today, overally, okay, whoever attended in the live session, and based on the students' response, in order to encourage the students in order to participate in the live sessions, for them, okay, for that purpose I am mentioning here the toppers of network theory subject regarding GATE score booster live sessions. Okay, right. Some students might have attended yesterday only, they couldn't attend it today, or some students might have attended only today, might not attended yesterday. No issue. Overall I am considering. Whoever participated, whoever joined in the live session, and whoever responded in the chart, and based on their performance, okay, for the questions which I have asked while discussing, and overall together I am mentioning here the toppers of network theory subject regarding GATE score booster, whoever attended during the live session. Okay. So whatever the names here I am mentioning, more or less you can consider all are same only. Don't consider that only whoever name I am writing first, they are the topper one, and whoever I am writing last, that is the topper 5. Not like that. Here in our class, we are considering all are like same category. Okay. So regarding toppers means whoever names I'm writing here on the screen, all are having equal caliber. Okay, in order to score very good marks in the coming GATE exam regarding network theory subject. Okay. Ravi from electrical. Ricky. Then Medha Kulkarni. From electrical. Then Abhishek Patel. Abhishek Patel, and then Ashni. Whoever actively participated during the live sessions regarding network theory subject, regarding our GATE score booster, and based on the students' performance, I have kept here the toppers of network theory subject regarding GATE score booster session. So whoever actively participated and based on their performance, I have represented here. Okay, right. So all these students are going to get very good marks in the upcoming GATE exam, and of course, whoever because of genuine reason or whatever maybe the other reasons, whoever not able to attend in the live session, no problem. Whatever the lectures, yesterday lecture and today lecture, it is already available in our YouTube channel. So whoever watching later, they can watch regarding, you can see the playlist regarding network theory subject GATE score booster, or with my title, with my name, you can see GATE score booster sessions regarding 2025 GATE exam, you can see with my name. Okay, so there you can find out the like regarding network theory subject, you people can watch later, and whoever watching from the recorded also, and whoever putting extra practice and efforts till your GATE exam, definitely you people also can get very good marks in the coming GATE exam regarding network theory subject. Okay, right. I hope all of you got maximum benefit from regarding network theory subject from these two sessions. All of you can share your experience, okay, before you attended these two sessions and after attending these two sessions, in terms of knowledge, in terms of confidence. The confidence is the most important, okay, right, in order to solve the network theory questions correctly. Okay, so the kind of confidence you people got and the kind of knowledge that you people received in these two sessions regarding network theory subject, all of you can share your valuable experience in the comment section, and whoever attending these sessions in the live, you people can mention the chat. Okay, definitely whatever the comments you people are mentioning, definitely that is going to help for your juniors or your friends. Okay, whoever want to, like whoever preparing for the coming GATE exam, definitely those students also will be watching these lectures and they are also getting maximum benefit from this series of lectures. Okay, right. Right, not but not the least. So I hope all of you aware regarding our Telegram channel. Whoever not yet joined our Telegram channel, link is already provided in the description of this particular video. All of you can join, it is free for everyone. Okay, so whatever the live sessions are happening in our YouTube channel at our IMS GATE Academy, okay, so all the schedules, updates you will be getting in this particular Telegram group, and after the session over, especially for the live lectures just like this one, okay, whatever faculties might have written on the digital board during the live session, that particular notes we are sharing in the PDF form right after the session getting over. Okay, so that PDFs you will be getting in this particular group. Okay, and all these other benefits also you are getting. It is free for everyone. All of you can share this valuable information with all of your friends as well. Okay, and so I hope the kind of questions we solved in the yesterday class and today class regarding network theory subject, definitely I can say it is a fantastic and marvelous. I hope all of you got maximum benefit from the questions that we have covered, right? So like this, whoever not enrolled at our IMS GATE Academy and whoever targeting for GATE 25 exam, for all those students, I am recommending you people can enroll for our Test Series Plus program. Whatever the variety of questions, tricky questions, okay, or most interesting questions, whichever questions you felt during our live GATE score booster sessions, regarding network theory subject, or even earlier I have done for digital circuit subject, right? Whoever might have got, sir, we have got more benefit by attending these sessions. Okay, definitely you can feel, you can get more greater experience if you are able to enroll for our test series plus program, because here for every subject we are providing chapter test, chapter level test, and then subject level test also, and then all the mock tests we are providing. All together you are having 130 plus online tests, because here the most important thing, whatever the knowledge you are having, you should cross check, okay, in the test whenever you are attempting, how your performance is there, and in which areas you are strong, in which areas you are facing issue, and even regarding time management, all the factors you can identify, and in whichever your strengths, those are assets for you, and in whichever areas you are facing the problem, you are noting that areas and you are overcoming test after test, right? That is the most important. And in addition to that, here we are providing 33 years GATE previous year questions along with the detailed solutions regarding technical subjects, and then regarding maths and general aptitude with respect to 6 branches, right? And even you are getting all these features also. So currently the limited time, the offer is running 20% offer for test series plus program. Regarding the Google form link already provided in the description of this particular video, kindly enroll for this particular program, whoever not yet enrolled at our IMS Gate Academy. Okay, for all the students, I am strongly recommending you people can share this valuable information and update to maximum friends, whoever writing upcoming GATE 25 exam. Okay, and yeah, so with this I am concluding here. I am thanking every student whoever attended during the live session, and even the students who are watching our GATE score booster sessions in the recorded form. Okay, each and every student, definitely they will be getting maximum benefit, and if you put your efforts in the right direction, and if you can do the revision accordingly, definitely you people can get very good marks in the upcoming GATE exam. Okay, that's all in this party session. So for EC branch and instrumentation branch, okay, I will be coming on live in the upcoming Saturday and Sunday regarding GATE score booster session of communication subject. Okay, so we'll meet you all regarding EC students and instrumentation students in the upcoming week. Okay, so thank you everyone.